multiple techniques such as lamentation, stemming, word tokenization, and all. So those are the techniques which we use in text analytics. But in the case of your numeric data, we don't face that issue. So the number of features are relatively small in the numeric data as compared to the text data. In the spam detector example, the features could include the following: that is, words in the email text for sure, sender address, the time of the day the mail was sent, or email contain a phrase, one weird trick. So these are the basically the features. A label is the thing we are predicting. So a label is a thing we are predicting. The y variable in simple linear regression. So we call a label as a dependent variable or a y variable. And it is present in both regression and classification problem. The label could be the future price of wheat, the kind of animal shown in the picture. So it can be the names, that is elephant, lion, or any of the animals. So that is more of a classification problem. The meaning of the audio clip, or just about anything. So it normally depends upon, basically there are two classes to it: regression and classification. So if it is continuous, such as the price of the wheat, the price of the house, the price of, you can say, some particular commodity, then it is a regression problem. Else if it is a classes, so if it is a bucketing type, uh, yes, no, true, false, that is like says discrete, or and kind of animal, that is whether a cat or a dog. So those are the classification problems. That is the one. Now talking about the next, sorry, next slide we have. So these are the features and label. Do anyone of you have any doubt till now up to here? Please, you can write in the chat window, you can unmute your mic.
No doubt currently.
Okay, thank you. So moving forward, so if I talk about, so these were the labels. So machine learning methods, so there are the various machine learning methods. So yeah, so our machine learning methods are divided into four types basically: supervised machine learning, unsupervised machine learning, semi-supervised machine learning algorithm, and reinforcement machine learning algorithm. Normally we normally don't focus on the semi-supervised one, but yeah, that is also one of the classes of machine learning methods or machine learning algorithms. So I will, so supervised, unsupervised, semi-supervised, and reinforcement. If I see the overall distribution, yeah, overall chart of machine learning, these are the three. So we do have machine learning, we do have a supervised learning here, and supervised learning can be divided into two: classification and regression. Classification can be like, classification is basically your the target or the dependent variable, or you can say your label are discrete. So I would say, see, you can actually, in order to like memorize the things, I would say try driving some name. So you can say class, so classification, as you know that classification, you can learn from the first four words: class, that is, your target variable or the dependent variable are classes. In classification problem, the dependent variable are classes such as true, false, spam, not spam, dog or cat. So something, whether the customer will churn or not. So that is what your classification identify, that is identify fraud detection, that whether there is a fraud or not. Image classification, like a cat or a dog. Customer retention, that is basically a churn prediction. And diagnostic, basically identifying whether the person is having a heart disease or not, heart, like cancer, yes or no, similar to that. Okay, so in this case, I do come up with one more question. So what do you mean by customer retention, or I can say the churning? So what do you mean by the churning? So do anyone of you is familiar with the churning concept? What do you mean by churning? So these are the business use cases like,
Whether a customer leaves the company or not, whether
uh,
or
okay, yeah, correct, Harmeet. So you're correct. So churning stands for a business implementation or a business use case where your companies identify that whether the customer is going to leave or not. That is the main thing. And why churning? And it is actually one of the most important thing which the company focuses upon. And I will let you know the reason. Okay, and anyone of you, like, what do you think that is the net worth of WhatsApp? Uh, An idea, estimate idea, you can write in the chat window. Like it will be in billions for sure. But like, yeah, yeah, Harmeet.
Mm, around 4 to 5 billions.
Uh, I think more than that. So it will be around 20 to 30 billions altogether. Yeah, but okay, now tell me one thing. How much your WhatsApp on? So like basically do WhatsApp on some particular properties altogether. So we are evaluating WhatsApp at WhatsApp at a value of 20 to 20, 30 billions. Okay, and that is a very huge amount altogether. 30 billions, if I say, uh, what actually constitute the what we say the valuation of WhatsApp? So is it the property they own, or is it some product they are owning? Why we are evaluating or why we are valuing WhatsApp to 30 billion value? That is
The
the main
goodwill,
question.
the brand name.
No, Armit. Thank you first of all for like being a quick respondent, but I will ask some other people so that I can have a understanding. So Baldev, this question goes to you. Why we are evaluating WhatsApp to 30 billion value? We know that they don't own any particular property altogether. Their offices are on rent, and they don't have only a single product altogether. But evaluating it to a 30 billion company is a quite a huge thing. So why WhatsApp is being valued to a 30 billion company? Baldev, am I audible? You can add in the chat window if you, as per public demand, highly uses. Okay. Okay, good to go. Bhuvi, can you let us know why why we evaluate, like why the valuation of WhatsApp is 30 billions? Or I can give a parallel question to you if I talk about in India also. So like the e-commerce companies, for example, Snapdeal went away, like it closed. Myntra also closed. The leading companies are your Amazon. Amazon is one of the leading company. Flipkart is another one, and their valuation are quite high. Why in the e-commerce platforms they don't like if I talk about Amazon, Paytm, Flipkart, they don't own any particular product. They are just the intermediators, but then also their business are in billions. Yeah, they provide some future of for business for sure, much of business accounts, but that is actually not the reason that the valuation are up to 30 billion. Bhuvi, are you there? Yes, studies, yes. So do I have to, you can unmute your mic if possible. So the first request would be to like, okay, the question is we are evaluating. So the question actually arises from one of the business use cases, that is churning. Okay, from that I've derived a question, that is why WhatsApp is being evaluated 30 billion company, even if they don't have any asset at present. I can say they don't have any assets, and they only have a product. And so most of the startups also have a product altogether, but they are not evaluated at 30 billion. Why WhatsApp is evaluated at 30 billion, or why Amazon, or you can say Flipkart are evaluated at a very high cost?
I think it's the number of users that is considered as an asset, which is why they are the more the number of users and the higher the value.
Correct. So Satyaj, if I talk about the revenue figures, in from the last 3 to 4 years, all your e-commerce platforms such as Amazon, Flipkart, like Amazon do have some positive numbers, but Flipkart, Paytm, they are in losses. The losses are up to minus. Their losses are up to 2,000 crore. That is how much the losses are. So actually, they are working on the future. Actually, the concept of e-commerce industry is that they will actually change the behavior of the customers, and going forward the you customers will only buy from them, and then that is the time they will earn. For example, if you see Paytm, they have started changing their behaviors altogether. Like when you started using the Paytm, they would give you cashback on each and everything, like 10,000 rupees cashback on a TV, on a fridge, and all those. Even on recharge, they were giving you 50% cashback. But now, if you see, there are no cashbacks altogether, because that is how, because they were working in losses. But now they see that okay, they have a fixed pool of customers or users who normally uses them, They will not go to the offline market, they will not go to shops to buy something, they will buy from Paytm, and then that is the place they will like start taking more money from the customers, because uh, actually they are in losses. Like for example, they are trying to change the customer behavior in the 4 to 5 years, and in that time they're giving huge discounts and people are buying from the online websites, and that time they don't go to the offline shops. So the offline shops, they think the offline market will close down uh, during these 4 to 5 years, like it will decrease, and they will be the major players. So revenue, they are negative. But yeah, Bobby, you are correct, actually it is an amount of users, the number of users, actually it is a reach. Okay, WhatsApp is being valuated 30 billion because the number of customers they can reach in a single go. That is why the business companies or the companies prefer WhatsApp for business altogether, because the number of users are in billions for them, and that is how they can earn money from the advertisement and all. At present, WhatsApp don't do any advertisement activity, but then also it is being valued highly because of the user count. Similar is the case with, you can say, Paytm and Amazon. At present, like or I can say the Flipkart one. So the 1% share of Flipkart is of 1 billion. This is my understanding. Like this was one of the sale rate which happened with Walmart. So the current valuation of Flipkart is up to 50 to 60 billion or 100 billion altogether. And think of a scenario that if all the customers who are using Flipkart leave Flipkart today itself, the value of Flipkart will go to zero in a single day. So it is actually the customers who are building the companies. The customer base is the main thing. That is how they bring in the funding, that okay, we are having this much amount of user base, so please give us money, and we do have a potential of earning a huge amount of profit going forward, so we'll give you a high return. That is what they say to the investors. If I talk about, so churning is the main concept, that okay, churning identifies whether a particular customer will leave your company or not. And that companies highly focus upon them is like how highly focus on this particular business use case or this particular team is, because they want to identify which customer is going to churn, which customer is going to leave the service or the company altogether and are going to their competitors. Because if one by one the customers start leaving, their valuation will go down, their sales will go down. That is why churning is a very important use case. And normally companies use various methods, such as they do see the time frequency. For example, if a customer was you can say shopping in a week, twice in a week, like earlier, but now it is shopping once in 2 months, then that is a signal of churning, and they will raise a flag. Then the particular teams will reach out to them, and they will give some royalty coupons and everything such like that. And same is the case with the telecom companies. They don't want. So actually, if you see, most of the companies are customer centric nowadays. The e-commerce, especially, like when a person will come to deliver some product altogether, either on Zomato or anything, they will ask you to please rate them, because ratings are taken at a very high consideration, or very high importance is given to them. So that is basically a customer retention stands for. And what that is the meaning of churning, that is whether a customer will leave or not. And I gave you the answer that why a customer leaving a company is so much important. Yeah, so much emphasis is given on that, that okay, a customer should not leave the company, why it is of highly centric or highly important for the company. That is what it is. So now talking about the other method of supervised learning is the regression. And in regression we do have your advertising popularity prediction. Okay, what will be the popularity for the same? Weather forecasting, market forecasting is one of the use cases. So in overall, the main thing in regression is the dependent variable, the target, the y will be a continuous number. And estimating life expectancy or population growth is also one of the use case. Now I do have another question. This question goes to Harmeet, you already gave answer. So this question goes to Jyoti. What are the various metrics by which we analyze the performance of a classification model? Jyoti.
Sorry, sir, can you repeat the question?
So the question is, what are the various metrics we use to judge the accuracy of a classification model? Yeah, performance. What are the various metrics we use to judge the performance of a classification model?
Matrix. You're talking
Yes.
about the matrix, right?
Yeah, I'm talking about the performance metrics of classification model. So, for example, if a model is being created, how you will identify that this model is a good or a bad one? That is a question in the layman terms.
Okay. So, sir, by its like how we are making the model by putting the each and every efforts in it, and by prediction and all.
Correct. Sorry.
That,
You all can answer me in the private chat window. Pooja, you are correct. But from that particular thing, we need to drive some more things. So you can answer me in private chat window. Jyoti, sorry, can you please repeat? Please pardon.
So I was telling that we can predict the whole scenario, and then we can get to know that is it a perfect. We can use it for the scenarios or not. That.
Okay. Okay, not correct. Sorry.
Yeah, it's
Uh,
fine.
uh, okay, Raghuram, I think Raghuram do some answers. So Raghuram, can you please let us know how do we will identify what are the various metrics we will use to identify the performance of a classification model? Yeah.
So if we have the p-value is less, then the accuracy will be the more.
So p-value is less than accuracy.
If p-value is less, then accuracy will be more. Based on if p-value is increases, then the
No,
accuracy.
you cannot be sure with that thing.
Okay.
So okay, what is the basically the metric for p-value? Why we are using the p-value? We will go one by one. So yeah, Raghuram, why we use p-value? Raghu, am I audible?
Yeah, not sure. That's what if it's 1 minus alpha, that p-value is less means its accuracy more.
Okay, so you use class like so you would have worked on the logistic regression. So how did you analyze the performance of the logistic regression model? P-value actually are used to identify the significance of your particular independent variable, whether they are useful or not, and the p-value should be less than 0.05. But accuracy, and so if they are significant, then also it is not necessary that you will get a higher accuracy. Yeah, they are used for hypothesis testing, Baldev, correct. But
R squared, AIK information criteria, AIC,
R square.
R square.
Okay. Rishabh, this question goes to you.
Okay. About the metrics,
Yeah. What are the various metrics we use to identify the
we
performance
calculate
of the
confusion
classification model?
metrics on classification. Like if we have a yes no answer, so if we predict yes or no, there are some chances like 50% on and all. So is that have a confusion matrix?
Correct. Confusion matrix is one of the answer. But okay, from confusion matrix you derive out some your performance matrix. So confusion matrix only have some numbers. Okay, what are the things your confusion matrix is representing to you? So normally confusion matrix there would be 4 blocks. So what
Yeah,
do
yeah, yeah.
these 4 numbers represent? This is the question.
True positive and true negative, false positive and false negative.
Okay, what do you mean by false positive?
False positive means we predict yes and also output was and no.
So false positive means the prediction was positive, or you can say
Yeah,
yes, but actually it was negative. Correct. So it
yeah,
is a false
yeah.
positive. So have you heard about sensitivity, specificity, accuracy? R square is
Yeah,
not for.
accuracy is about number of correct prediction about the total number of predictions made.
No, so sensitivity is not about the prediction. That is basically your accuracy
Oh,
can be.
yeah, I heard about the uh, uh, word, but I didn't proper what's
Okay, no
the
issue.
yeah.
Nandini, can you explain me what are the various metrics of classification?
Sorry, can you come again?
Uh, Okay, what are the, so like Rishabh like brought up the answer till confusion matrix. So we have TPT and FPF in there. So what are the, so we actually create some performance criterias in our classification model.
Mhm.
So what are those? So I named two of those. Sensitivity is one, specificity is another one, or you can say accuracy is the third one. So what are the other metrics we can use to identify the model
See, I don't
performance
know
in a
correct words, so
classification?
I'll make it explanation. So classification is
Sure.
like whether the customer is like that or not. Okay. So
Correct.
it's also depends upon the feedback. I mean maximum of the feedback that we got from the customer.
Hmm.
So we can consider the rating as one of the main criteria for classification.
Mm, sorry, can you repeat the last line? We can consider.
Rating,
Uh,
customers rating
I think
as
that
one
can
of
be
the
okay.
main criteria of classification.
No, I would say because Nandini, I can say by rating you can actually analyze the performance of the product, that how good the
Okay.
product is. If the rating is good, then the product
Mm-hmm.
is good for sure, based on the reviews and all.
Mm-hmm.
But I want to see,
Mm-hmm.
because when I'm creating a classification model where I'll provide this data to the machine, and I want
Mm-hmm.
to identify how machine is now, whether new data, how good the machine is able to predict. Correct. So
Yeah.
rating depicts the quality of the product, that how good the product is. But in classification model, we want to analyze some metrics by, okay, by which we can say this machine learning model is good. That whether it is able to predict better in a, whether the machine learning model is able to predict in a more accurate way or not. So that is the metrics I'm talking about.
Okay, so maybe how many customer has purchased one product? Okay, so we will be in sales we'll be having the history of the customers who purchased one product. So the maximum number of customers purchased one product we can
Okay,
consider
that
that.
actually can be the idea part, but
I mean,
okay, yeah, sure. Thank you for those, for the your answer. Sahil, yeah, Satej will answer this. So, what are the various metrics? Satej, Bhuvi, your answer for the sensitivity is correct. Satej, am I audible to you? Surya, if you can answer the question, what are the various metrics by which we can analyze the performance of a classification model? Yash, question goes to you.
Yes, actually, I'm also familiar with the confusion matrix.
Okay.
Yeah, apart from that, I'm not getting a different matrix. Like,
Okay, so I will just name them up now.
okay.
So we do have sensitivity. So basically, like I will cover all those in explanation. How do we identify sensitivity? And I will show you in the Excel file like how all the formula for them. So from confusion matrix, you identify sensitivity, specificity, or you can say recall, precision, F1 score, and accuracy. These are the main metrics by which these are known as a classification report. So these values we get from the classification report, or these are what we derive from the confusion matrix altogether. And your recall of class one is similar to your sensitivity, and recall of class zero is known as specificity. That is what we have. And actually, you can use the AIC value also. That is the error which you have. And actually, you can use the ROC AUC curve. That is another method. So these are the classification metrics by which we identify the accuracy of a model, and we will discuss, and going forward we'll discuss on the which particular, for which business use case we are going to use which metric, because accuracy is not the correct go-to metric for each and every use case. We do have some issue with the oversampling. So when the data distribution is not correct, for example, we do have two classes, minority and majority class. That is, in classification problem there are two classes, spam or not spam. So data for spam is 95. So you have 100 rows, out of those 95 is for spam and 5 are for non-spam. So when you create a training model, when you train a model on that, it will be highly biased toward the spam one. So you cannot use accuracy there. In that case, we will be using F1 score. So that is with the classification. And okay, we do have another question. So what are the various metrics for regression? We will start with Raghu again. So Raghu.
Can we use the chi-square, Gini, and for this one, apart from confusion matrix?
Can you use
Gini, information gain.
Gini? So if you talk about Gini impurity or information gain, actually they are not used in, they are not classification matrix. Actually, they are the you can say methods or formulas used in the decision tree working. So using those, the decision tree make the splits. So those are not for classification. They are used in your decision tree algorithm, like using Gini impurity identifies which particular feature or which particular independent variable is highly impure and is not able to identify the target or the dependent variable. So that is where you use Gini impurity or information gain. So you cannot use those in the classification matrix. So this time the question is how, what are the various metrics for regression problem? Pooja, your second one is correct. So this question goes to Yuvan. Yuvan, are you there? Correct, Bhuvi. This is the one which you use. Yuvan, sorry. Swati, this question goes to you. Please, I would request all of you, if you don't know the answer, then also you can say, you can write in the chat window, okay, I'm not clear with this. Please respond to my requests. That is one of the requests I would ask. Yeah, Swati, correct. You can mute your mic. I think your answer is correct. And feel free, like, see, I know you are here for learning. So you might not know about the solution. So that is good enough. So there is no issue with that.
Yes, we have
So-
R square. We can calculate R square and then we can know
Correct.
how accurate our model is accordingly.
Correct. R square is one of the metrics. So Hermit, R square will come in regression. It will not come in the classification modeling. That is the first thing. So Swati, R square, correct. Baldev, what are the other metrics which you can use for regression? Baldev, am I audible? Please unmute your mic. Correct. MAE. So Baldev wrote in the chat window. So he is saying mean absolute error. Correct. It is one of the metric which you can also use. But yeah, cat correct one. That can be one. Bhuvi, you can name any one of these metrics. Any one metric. So R square. Okay. No issue. So okay, I will just name them up. So Rishabh, yeah, you can answer. You have written the correct one. So comprising most of them. Correlation matrix, Sahil, cannot be used to identify whether your regression model is correct or not. It can be used for feature selection, that identifying okay which particular features or independent variables are highly correlated with the target, and actually they will impact the target variable altogether. So you can use those for identifying the feature or the independent variables, but not for identifying whether the model will be accurate or not. Yeah, Rishabh.
There are three metrics in that. First one is R square, like mean square error, and the second one is absolute mean
R
square
square
error.
okay, R square and mean square error are different. R square is one, mean square error is the another one.
Yeah.
Yeah, you can move.
MAE, it's mean absolute
Mean
error.
absolute error.
Yeah, and
Correct.
MSE is mean squared error, and other one is
Okay.
R square, and is related to with them like root mean squared. There are
Correct. RMSC is the another one, which is basically the root of the MSC.
yeah
Correct.
yeah, and
And
another one is like R squared related with R square, I think.
it is adjusted R square.
Yeah.
So the left one is adjusted R square, And there is one more important metric actually which we normally use in the business or in the corporate sector, that is a MAPE, if you would have heard about. So MAPE stands for mean absolute percentage error.
Yeah, map.
So the
Map.
client normally asks, yeah, the client will for sure ask you for the MAPE and the R square. They will not ask you what is RMSE or MSC. Reason being, MSC and RMSC are actually the numbers, whereas MAPE is the percentage change from the actual and the predicted value. That is how much percentage away your predicted values are, your predicted value are away from. So how much percent of predicted value are deviated from the actual values. That is what your MAP say, and that is actually easy for the business people or the client to understand. So we normally tell the client the MAP values for your model, and they are highly used. That is the one. So this is what we have for the classification and the regression. Any question anyone of you have, please ask.
Gurdeep, can you repeat the last part of it? Mean
It is
absolute.
MAP. It is mean absolute percentage error.
Okay.
Okay, and this is normally what the client normally prefer and ask. There is one question I will ask it to Rishabh only. So Rishabh, how you will calculate the RMSC? What is like the process, yeah, the steps you will use for calculating RMSC?
RMSC is used for like about the outliers, like more sensitive to outliers.
Correct. So normally this is the answer which you, so the answer which you are giving is the main difference between MA and RMSC. So RMSC is more sensitive to outlier, whereas MA is not. But I am asking, what is the formula for calculating, like for RMSC? If you have actual and predicted value, how you will calculate RMSC?
I didn't get properly, but there is a some y minus yi whole square of root under root. I didn't get properly.
Okay, no issue, but yeah, great answer. Like you were able to understand them. So that is what I'm thinking to cover, because actually I want to know like how much familiar you with the machine learning and with the regard basic terminology. So I'll try covering them too.
Yeah.
So this.
Gurdeep, I have a question. In linear regression, we calculate like clearing the data and about the EDA part on it, and um, we divide in data in a test or trend, and we create a model and predict the data. And after that, in my our class, they will not able to evaluate the map, like you ask about the map or R square. They are mainly used like R square, but not including the map. So
Hmm.
so mainly, what's the major difference between R square and map?
That I will cover. So Rishabh, I will go step by step. So what I will do is I will explain you the working of each and every what I say
Yeah,
metric.
yeah. I also
How do
learned
we?
with other platform. So they in last they also evaluate a map, and it's give me some like percentage. So it's like less than 15 or 10%. We do the right prediction, right?
Yeah, correct. So actually, if I talk about R square, only tells you how much variance the model is able to cover for the actual data. But it might be a case that your R square is good, it is up to 90%, but your MAP is bad. Normally, client focus mainly on the MAP part, because your MAP tells you, because MAP is of main use case for them. It actually tells that how much your predictions are far from your actual data. Okay, so it might be that, okay, actually the demand was for 1 lakh, but your model say, oh, your demand will be of 2 lakh, and you actually have produced 2 lakh items for the customers, and only 1 lakh are sold. So the remaining 1 lakh will be a huge loss for the company, because they need to invest on the inventory, and it might get expired. So that is where your MAP comes into play. The client will see the MAP first. So MAP is the most important metric in the
Yeah.
while dealing with the client. So I will actually, what I will do is uh, these all questions are actually to understand how much you are clear with the basics and all. So what I will do is I'll just make you go through the various.
Gurdeep, quick question. Just to confirm, this MAP is for regression analysis, right? Not
Correct.
for classification, right?
No, no. For classification, I'm just repeating it again. You can all have a note for you can make a note for the same. For classification, we have your confusion matrix. So I'm just telling you the names, and then we will be relating them up later on. So for classification, you have confusion matrix, or you can say classification report. Classification report consists of your so the main metrics are confusion matrix, and from that we derive recall, precision, F1 score, recall, precision, F1 score, and accuracy. Accuracy is a separate metric, and we also have sensitivity, specificity. These are the main metrics which we normally use, or you can say ROC, AUC curve. But we normally can fit with the F1 score. Like F1 score and accuracy will give you the overall gist for the same. And for regression, we have MSC, mean squared error, RMSC. I will cover them up, Bhuvi. MSC, RMSC, R square, adjusted R square, and your MAPE. So these are for your regression models. And you cannot use them interchangeably, that you cannot use the matrix of classification in regression. That will not work. And for regression, you cannot use in the classification. Yeah.
Gurdeep, I have one more question about the cleaning data or missing values data. Uh, I have a data from Analytics Vidya. So is that data is like Big Mart sales prediction. So is that there are two CSV file like train and test data. So firstly, I will R bind on both file. So it will be a one data set, and I will done all the things on it like apply function or NL or all. So I have seen I have a 14,204 rows in my data frame, and in test there is a 8,000 or 5,000. So I have seen there is a missing values in the three variables like item weights 2439 and outlet size is 4,000. So if I divide uh, if sorry, uh, uh, just a second, if I have a missing values in outlet size like 4,000, so we can determine there are three types of outlet size like medium, small, and large. So I want key, if I calculate the in आउटलेट साइज तो उसमें ऐसा था सर कि मेजरली एनए पार्ट्स में ज्यादा मतलब वैल्यूज है। सो मुझे अगर उसको मिसिंग वैल्यूज करना है तो मैं उसमें मीडियन और मीन के थ्रू कर सकता हूँ, बट मेजरली मुझे मीन ही करना चाहिए ना।
सी एक्चुअली आप मेन यूज नहीं कर सकते बिकॉज आउटलेट आईडी अगर आप साइज के साथ चेक करोगे तो 3 साइज यू नीड टू यूज द मोड, you need to use the mode. You can use because it will be with the size. Now with size you can get to know, okay, there are three sizes, I think small, medium, and large. How much I remember the data set with so you can get to know that this particular ID like with this particular outlet, or you can use actually you're talking about the outlet ID, correct?
Yes.
So there are particular variables, I think outlet location, that so you can use actually two variables, the size of the outlet and the city tier.
Yeah.
Okay, so you can actually use those to identify. So what you can do is with particular outlet IDs you can identify, okay, which particular outlet was having I actually need to see that because I don't remember it completely. With outlet ID you can see, okay, which particular class it was lying to. Okay, like whether it was size or it was a bigger in size. So actually using outlets you can fill the size of the same.
Okay.
Which size it is of. Yeah, you can fill the missing values of the column size.
I see the count of the all the classes like high having 1500, medium having 4600, and small having 3900, and NA have 4000. So I am using a medium on all NA values.
Actually you are doing it on outlet IDs, correct?
Yeah, like outlet
Okay, outlet ID, it means they are
Outlet
actually
ID like outlet identifier about.
correct. Outlet identifier means, for example, if you have a big bazaar shop in Delhi, if you can have in multiple places of Delhi, like one is in CP, you can have a particular ID for that. For example, I can say there are multiple states in India, and for each state we can have a ID 1, 2, 3, 4, 5, 6, 7, 8. So your median value will not work because it is basically a value you are having for that particular ID.
Yeah.
That is a unique representation of that particular outlet.
Yes.
So if you will use median value, you might not have an outlet with that particular ID itself.
Yeah. But
Those
uh,
cases, yeah.
in that part we are not calculating. We are not able to calculate a median, as we see, because there is a like a categorical data. So we can see the data and arrange them.
Okay, what I will do is actually we can cover that problem in one of the algorithms, and that it will actually help us. So we'll be solving that one. I will take that problem as one. Okay.
Yeah, I'll share with you. We can also solve it.
Sure, like you can just share it with me and I will let you know the inputs on the same. What we can do is actually I will just take that problem because at this stage we are identifying the various metrics and also I think so working on it on a particular project will help us out.
Yeah,
So what I will do is you're talking about the big mart sales, correct?
yeah.
Yeah, I will just take that. And it is more of a say identifying the sales, so it is a regression problem. So we will take that in up in one of the algorithms. So and we'll do all the tasks. So I think
Yeah, we are
we
doing linear regression. I'll share with you on mail.
sure, you can just share it. Thank you.
Thank you.
So these are the main classes of supervised learning, that is classification, regression, and I talked about just the matrix. Then we have the unsupervised one. In unsupervised, we do have clustering and dimensionality reduction. So clustering actually is used. So in unsupervised, so now talking about the main difference between supervised, unsupervised, supervised, you have both dependent and independent variables. Whereas in unsupervised, you only have independent variables or the features. So in independent variables, so you are only having the independent variables and you don't have the dependent variables. So what your unsupervised learning do, if I talk about specifically about the clustering part, so your unsupervised, so your clustering helps in identifying the patterns from only the features. That is one of the case I will cover. For example, you are having a data about a customer, like you are having a banking data, and you are having basically the income of the person, the expenditure, the age, and you will identify clustering technique to identify okay which particular, so how you will cluster the total data on the basis of their expenditure. So that so if I talk about the banking client, what we will do is we will cluster the data and we will create clusters or groupings and will identify that which persons are having high income and high expenditure, and actually we can sell them credit card or we can sell them a loan, and identify a person who are having a low income but high expenditure. Those are the groups which from which we'll save ourselves. The bank will save them because those are the defaulters. Otherwise the person having a medium income, medium expenditure, and for them we can like also provide a smaller loans, and we can tell them okay you can have a FD with us. So you create actually clusters from only that data because you don't have a dependent variable, and after creating cluster you can actually convert that problem from unsupervised to supervised, because that cluster value will become a dependent class now, and you can use a classification algorithm because you will get a cluster ID. So I'll cover these up. I will cover a business use case of banking data on this. The next one is dimensionality reduction. So in dimensionality reduction, the algorithm I'm going to cover is PCA, that is principal component analysis, and it is used to. So what we think is dimensional reduction. So it is used to reduce the dimensions of the features. That is, for example, if your features are 10, then using dimensionality reduction or PCA, I will convert your 10 features to only 3 features. Okay. Or I can say a simple example can be, for example, you have 2 columns, the weight and the height of a person. Then actually we can create a single column, that is BMI index, using both of these. And that is basically reducing the features. So we will remove height and weight and we will only incorporate your BMI. So that is reducing the dimension from 2 to 1. Or I can say if you have price and the discount of a particular product, so you have the price of it, you have to do have the discount value which was provided. So what we can do is we can incorporate a new column or new feature, that is discounted price. And a discounted price will be what we say will be derived from price and discount, so we can remove price and discount and can use discounted price. So these are much of the feature engineering technique which we can use, and that is somewhat similar to the dimensional reduction, but we do have some algorithm specifically, that is PCA, by which will be reducing the dimensions. So that is the one. Now the next one is reinforcement learning. If I talk about, so reinforcement learning actually works on the concept of reward and penalize. That if your particular machine is learning in the correct way altogether, then it will be rewarded, and if it is going for like doing wrong prediction, then it will be penalized. That is, there is a pointer, a scorer for that. You would have seen that in multiple times on LinkedIn and all that, a robot started walking and how it will learn. So that is basically with the reinforcement learning. So we use reinforcement learning in gamings, skill acquisition, and robot navigation. So these are the main field, but I would say reinforcement learning is still in the development phase, and the mostly the matured ones are unsupervised and supervised. So they are highly used. Whereas reinforcement, I think it is more in the research at present. We don't have some solid algorithms to work upon. So talking about, so this is your supervised algorithm. So supervised machine learning algorithm can apply what has been learned in the past to new data using labeled example and prediction future event. So this is the supervised learning part, having both. And if I talk about unsupervised, with form information used to train neither classification nor label. So there are hidden pattern in the unlabeled data. So that is what we identify in the unsupervised one. There was one more class if we discuss, that is semi-supervised. Actually, if I talk about semi-supervised, in this we do have data in what we say division format. That is, half of the data is having a label and half of the data is not having a label. So in that case, what we can do is we can from semi-supervised we can create a supervised algorithm altogether. We can convert the problem to supervised. That is how, for example, and the data for which we are having the label, we will use that data to create a model and can do the prediction on the rest of the data who are not having any model altogether. So this is your semi-supervised algorithm, falls somewhere in between supervised and supervised, since they use both labeled and unlabeled data for training. Okay, so what you can do is you can use unlabeled data for clustering and labeled data for creating a supervised, or you can say a regression problem based on the data you have. Labeled data, large amount of unlabeled data, but it depends upon case to case. So normally the practice what we do is, from the labeled data we create an algorithm, or you can say a machine learning model, that is classification or regression, and then we make the prediction on the unlabeled data. That is what we do. And reinforcement learning is a method that interacts with its environment by producing action and discover error reward. That is the main context we have. So if I show you the complete real scenario, see, these are the one big data visualization, or I can say this is a more in-depth analysis. So machine learning can be divided into like 4 types. That is classification, classical learning, that is supervised, unsupervised. Then comes your reinforcement learning. Then comes your ensemble methods. So ensemble, for example, bagging and boosting. And bagging, basically random forest represent your bagging method, whereas your light GBM, max gboost, they represent your boosting. So I'll cover them, difference between them. And one is a stacking one, that is using various algorithms combined to make the prediction. And then we have the deep learning part, that is neural networks. We have CNN, LSTM, GRU, and vanilla neural network, in which we make the predictions. So this is the overall structure of your machine learning, I can say AI field, data science field. These are the various technical structure or the architecture. Do anyone of you have any doubt till now? Please let me know. So Raghuram, Baldev, Bhuvi, any doubt? Pooja,
Hello.
Rishabh.
Hello, Gurdeep.
Yeah, yeah.
Yeah, sure. Can you give example of problem statements for unsupervised learning?
A problem statement for unsupervised learning can be, for example, you have a banking data and you don't have a particular. So, for example, you have a person age, income, and expenditure. Correct. You don't have a target variable. So this is more of a data you have, and you want to identify some patterns out of it. For example, you want to identify a person whom you can give a loan, or whom you can sell a credit card. Correct. Or whom
Yeah.
you can sell a RD type of thing, that is monthly deposit, or whom you can sell a SIP. So that is what we will do, is we will create clusters, we will create grouping on the basis of income, expenditure, or age. So we'll use three categories, that is age, income, and expenditure. We will create grouping from the complete data. We will get groups of people, group of customers who will prefer what. On the basis of that pattern, we will sell them our services. Or I can say it can be like you have some data altogether and you have various services, for example, like on the basis of or I can say it's locality, like if you have demographics data. Correct. And you actually are demographic data with particular having income per, like per capita income, or the parking slots, and you are an automobile company such as Audi and BMW, so you are the MD of those, and you want to identify where I can open my stores. So in that case also you will do clustering. You will create clusters, that which particular cluster do have people with higher income, and the area where like the people living are having a higher income, so I can open a showroom there. So because if you would have seen your Audi, BMW, these showrooms are not present everywhere. Actually there is a huge research which goes on at the back end to analyze where they can open their showroom and where actually there will be sales, because opening showrooms like Maruti will not help them out, because every person does not buy them out. And that is basically a segment of customers who actually are interested in those. So identifying places or pitching to specific customers, in that cases we use the clustering techniques or unsupervised one. I will cover a use case of banking. I think it will be more clear that time. Yes. Any
Yeah,
more?
fine.
Okay, yeah, thank you. Any more doubt any other people have? Parul, Pooja, Sahil, Satej, Surya, Saraswati. Any more doubt regarding the things covered? If you want, I can just reiterate a particular topic if you want.
Just one question.
Yes, Sahil.
According to this mind map, are neural networks a completely different class
Yeah, actually, if
of
I talk
machine
about,
learning?
so yeah, so we do have machine learning. If I say this area is your machine learning, let me just show you. Just yeah, if I show you, your this area is of machine learning. I can say yeah, these. Sorry. So I can say these is your machine learning stuff,
Okay.
and this is what we call as deep learning. So the architecture of deep learning, actually, see, the main difference is in machine learning, it is simple algorithms which you import from sklearn and all, and simply implemented. The structure remains the same. Whereas in deep learning, we do have the neural networks, and there are different type of neural networks. So the implementation altogether changes. Like we need to use keras, and there are layers. That is hidden layer, input layer, output layer, the activation functions. So that is actually deep learning is a different field altogether, and it is used when the data is quite huge and highly complex. Then we go for the deep
So,
learning.
as a data scientist, will I ever come across using deep learning algorithms in the
As a
future?
data scientist, for sure, if the data, see, okay, let me just like make one thing like more clear. Like for example, most of your business problem can be solved using machine learning. Okay,
Okay.
most of the business problem can be solved using machine learning, but when it comes to some highly complex problems such as image video analytics, identifying, because image video analytics so if I talk about image video analytics, they are actually relied upon spatial analysis. Our image is basically a pixel, and we analyze the grouping of those pixels. So in that, actually we use CNN, the convolution neural network. Okay, so those are the places
Okay.
where specifically you can say your these neural networks comes into play. Or I can say, for example, in time series we normally use arima, sarimax, sarima and all. But like if you're not getting good accuracy using those, so we do have a LSTM algorithm here, stands for long short term memory network, and is a type of neural network. It normally gives you good accuracy over your time series. So what normally we do in practice is, when you will be in your corporate sector and when you get a business problem, you will try solving it using machine learning first. That is using random
Okay.
forest, XGBoost, LightGBM and all. And if you're able to get good accuracy, then it is good and fine. If you're not able to get good accuracy with even after performing multiple commutation combination of various things, then you will switch to deep learning.
Okay.
Then you
Okay.
will switch to
Thanks.
deep learning, because actually identifying the, so in deep learning the main issue is identifying the architecture, that how many layers you will use, how many nodes. So that actually takes a huge amount of time. So we give the
Understood.
first, yeah, we give the first kick to the machine learning, and if it works, it is great. If it doesn't, then we go to the deep learning.
And we use a different software for deep learning?
No, it is Python, Jupyter Notebook. Anaconda supports everything.
Okay.
So it will be a different library you will be using. So for machine learning, you're using sklearn. I
Okay.
gave you a list of, so for machine learning, you will be using sklearn. For deep learning, you will be using Keras.
Understood. Understood. Okay. Thanks.
Okay, thank you. Welcome. Any more doubt anyone of you have in this? Okay, and after this, if I just show, just give me a second. Yeah, if so, this was the overall mind map. If I show you the overall flow, so this is the overall flow of machine learning process. So first phase is the data collection phase, then is the data preparation, then we work on, so after preparing the data we choose a model, that is selection of a model basis the type of data you have. That is you will be choosing a classification algorithm, or you will be choosing a regression one, or whichever you want to choose, or clustering one. Then you will perform the training, and in training phase it is more of implementing the algorithm to the data. Then you will do the evaluation. So evaluation will be done on the basis of the matrix which I told you. For classification we will be using recall, precision, F1 score, accuracy and all those. And for regression we have me part square and everything. That is what we'll be using for the evaluation phase. Yeah, that is what we'll be using for the evaluation phase. That is for training. After evaluation, and that then comes the parameter tuning part. That is, for example, you have used random forest but you're not getting good accuracy. Then there are multiple parameters you have in random forest, such as number of trees, estimators, maximum depth, how much will go, number of features you want to select and all those. So we'll tune in the parameters, and then you will try to gain the accuracy, and then we'll make the prediction part. So this is prediction is on the out of bound data. So when you evaluate, actually, for example, so there are difference between evaluation and prediction. So it will be when you have in total 10,000 rows. So in that you will use 7,000 rows for training and 3,000 rows for the testing part. So on that 3,000 rows, you will do the evaluation and everything. So your model will be a good fit. Like if your model is a good fit, then you will do the prediction of future data if the model is approved. And actually it is a, so if I talk about these methods, these two are like, I can say there will be a line similar to this. So you will change the you will change the parameters, and here you will do the evaluation. So this is how it will work. So it is a to and fro method here, and when you have a good model, then you will make the prediction. So this is how the complete life cycle. And okay, another question for you all is, anyone can answer if you want. So how actually, for example, you have done the training part, you have created the model. For example, you want to, for example, like your new data will be coming after a month, and you have created a model now. So how you will save the model for future use? That is a deployment phase. So after this, it will be a deployment phase. So how you will deploy the model? Bhuvi, any answer? Model deployment.
Sorry, what is the question, Gurudev?
So the question is, for example, you have created a machine learning model and it is having a very good accuracy, like classification, it is having a very good accuracy altogether. It is a superb model. But now your new data will come from the client after a month. So you have made the prediction till now, but your new data, so the data is fresh in a month cycle. So you have to make the prediction in the next month. And you have the model being created. So how you will save the model?
We can deploy the model. Like,
Not question this question. Okay, I think question is clear, but sorry, you don't have to give the answer. So Bovi will give the answer.
okay, okay.
Bovi, are you there? Okay. Okay, not sure, no issue. But thank you for the response. Saitej. Saitej, do you have an answer for this thing?
No, sir, not sure.
Okay. Okay. So anyone who knows the answer can respond. Okay. One more thing. Raghu, do you want to like give your inputs on this? How will be saving the model for future prediction? Okay. Yeah.
Can we use the past data?
Actually, see, you are correct. You will use the past data for training your model, but you will get new data from the client after a month. You have consumed the till date data for creating the model, testing it, but for prediction it will be coming after a month. So you will save the model in a pickle format. So you would have heard you can save the model in a pickle file, or there is a jobly file, but mainly we use the pickle format. So you will save your machine learning model in a pickle file, as a pickle file. I will cover that part, and then you can load the model back again, and then you can make the prediction. So that is how. And regarding the deployment, you can deploy it on a cloud, that is on AWS or on GCP or on IBM or Azure. You can deploy it there, and you can share the API with the client, that is application programming interface for that model with the client, so that they can make the prediction. Or you can share the pickle file with them. Pickle file actually will, so you will convert the model to a object, a file format type .pkl, and then you can actually load it again in Python, and you will use the library pickle for it, pickle. So the library name is pickle. You will use this library to save your model as a file, and you will load it or save it. You will load it into the memory or into your Python code by simply loading the pickle file. So
Gurdeep, one
yeah.
question. So if we hand over the pickle model or pickle file, let's say, is it like transferring the ownership? We are giving the complete raw data to the client?
Actually, so this is a very good question altogether. So Pooja, like when you transfer, this is normally what you have in the SOW. So when you sign a SOW with the client will let you know that what are their requirements, and you will be charging accordingly. So when you transfer a pickle file to the client, so normally there are two type of things, like how a project goes. The first one is a service type, that is you create a model, and the client will at a monthly level share the data with you, the new data which they have. You will make the prediction on them, and for each prediction you will charge something. Correct, it will be a service based type, that each monthly there will be a charging, that okay, you can share 1 million data with us, and we'll charge you like 1 lakh, or you can say 1 million for you, 1 million to you, and for the prediction part. That is the one type of model which we have. The second one is, the client will say, okay, I will pay you higher in the starting only, and you need to share the pickle file with me. So in that case, you share the pickle file. So actually there is one good thing: when you share the pickle file, that pickle file is simply an object. The client will not get to know what particular parameters you have used while creating the model, or which particular algorithm did you have used. So that pickle file is much of a, so it is encrypted type file. Actually you cannot identify which model is present in that, what parameters are being used. So the client can make predictions, but they will not get to know what are the various parameters are being used, which particular algorithm is there. So that is how your work will be saved. And there is one more thing: normally the models are refreshed after every 5 to 6 month cycle. That is a normal practice we have in the industry, that you need to refresh your model after in a 5 to 6 month cycle, because we have a tendency, or we have a thought process that in 5 to 6 months the trend in the industry changes a lot, and your previous model will like give bad result, or like you actually on a daily month prediction scale, so for the first month you will get a very good predictions, very good accuracy altogether, but over 5 to 6 months you will see that okay, the accuracy is going down because there are new trends coming in, new features coming in. So then you will rebuild the model again, or you will refresh the model with new data. So that is what we have. So Pooja, did I answer your question? Or
Yeah, Gurdeep, absolutely. Thank you.
thank you, Pooja. Any more question anyone of you have? So after in this, like if I move to the next slide, it is basically your example self-driving car. I think this is the one which I shared with you earlier. And so these are the regression algorithm which we have, the popular one, linear, KNN regressor, SVM regressor, decision tree, random forest, and classification algorithms also are this. So I can say, okay, so there is one thing, KNN, SVM, decision tree, random forest. These all have your, these all do support classification regression, and naive Bayes only supports classification, logistic regression only supports classification, and your linear regression only supports regression. So these all algorithms are common. These 4 algorithms are common. You can use them in regression and classification both. And the unique one are linear regression, which can be used only in regression, and logistic can only be used in classification, and naive Bayes can only be used in classification, not in regression. So these 4 algorithms remain common. And so this is and to this particular slide, uh, so what we can do is we can go for a break for 20 minutes, and we will just start our class back at 10:15, and then we will start with what I will do is I will just start with either the matrix, the classification matrix which we covered, or the regression matrix which we covered, telling you how do we calculate them in a Excel file only. I will just tell you how all the backend formulas. Of course, we will implement them in Python when we'll implement the algorithm, but that will make you go through the basics or the inner working of them in Excel, so that it is quite clear to you, creating the confusion matrix and everything. Okay, so that is what we will do. So we will go for a break, and we will get back at 10:15 and 17. I'm just writing the time here. So any doubt anyone of you have? I like. Sure, I will share this PPT with you. I will share this PPT which I'm having, so that it will actually. So these PPTs actually, this complete flow will help you in clearing your thoughts. That okay, where which particular part of the thing you're doing. Like if you're working here, then you are here. This is a different thing which you have.
Hello, Gurdeep. In a
Yes.
previous slide, like you said, there are similar with uh, like algorithms. You go for the unsupervised learning and supervised learning.
Yeah, I know you're talking about this one. Yeah.
Yeah. So you said KNN, SVM, data decision tree, and random forest is same. So why we are using differently and different names?
Okay, so I think there's a gap. So basically, these algorithms are not same.
Okay.
The KNN is different, SVM is different, decision tree is different,
Like
random forest is the
scenario,
abbreviation of decision tree.
about the scenario, there are different methods.
No, so actually, what I was saying is that you can actually use KNN for both regression and classification tasks. You can use both SVM for both regression and classification, decision tree. Whereas you can use linear regression only for regression, not for classification. That is what I was saying.
Okay, okay, okay,
Yeah.
okay, okay, okay. Thank you.
Okay, thank you. Welcome, welcome, Rishabh. So we'll go for a break. We'll get back at 10:20 now, and then we will start our class. Thank you all. Take care. I will share this PPT for sure at the end of the class, and thank you.
Mm,
Hello everyone. Welcome back. Am I audible to all of you? Okay. Thank you for the response. So we have gone through the various divisions of machine learning algorithm and like classification regression. What are the various algorithms? What are the main difference between them? And main difference between supervised and supervised. So we have covered these part. We were talking about like classification regressions. What are the various metrics we use to identify the performance of the model? Correct. So these were the topics which we were discussing altogether. So what I will do now is we will actually do identify the various metrics such as confusion matrix, how the confusion matrix is being created, how do we calculate recall, how do we calculate precision, and each and everything. We are going to implement that. That is the backward working, back end working, how these things are calculated on Excel. So on Excel, actually, the preference I'm giving to Excel is so that you are able to understand the backend working. Otherwise, the direct implementation will be doing in the Python itself. So you will get to know the backend working, how your MAP is calculated, how your MSC is calculated, basis the actual and the predicted value. and that is how you can see the deviations and everything. So I will just share my screen, and first we will start with a classification, or we can start with the regression first. I think that is one will be more easier to understand. So do let me know when you're able to see the screen.
Yes, we can able this see the screen.
Oh, great. So what I'm doing is, so this is, so we are actually will be calculating the various metrics for the regression problem. We will be seeing the formulas how the metrics are calculated. So the various metrics we will be identifying are, and I will just give you some questions regarding. So I can say actually these are more of your actual values. So okay, you normally what you do, you normally on the complete data you train and you divide the data into train and test. So for example, if there are 100 rows, if there are 100 rows, 70 rows you will use for training and 30 rows you will use for testing. So on that 70 rows, you will train your algorithm. On the 30 rows, you will test your algorithm. So test means you will actually have the y value, which are here. So on test mean you will actually have the y value, and you will use your model which you have created over these 70 rows. On the data which was present in these 70 rows, you have created a model using it, and you will make the predictions using that model over the test data, which is this value. So you can see these are some of dummy values which I'm using just for the sake of explanation. That is, you will be able to easily understand them. So let me just freeze this first row first of all. Okay, so these are the values we have, and these are the actual values we have, and these are the predicted values. Okay, so now what we will do is we will just calculate the various metrics, such as, so in this case we will be calculating MAPE, MSC, RMSC. So we will calculate MAE. So what we will do, we will calculate MAPE, RMSC, MSC, and MAE from these. And just give me a second. We will calculate the R square also, so that you can get to know the inner working for the same. So till now, any one of you have any doubt regarding what do you mean by actual, what do you mean by prediction? So these are the actual values. Actual, you can say sales. So I can say not y actual, I can say actual sales. So this is more of a sales data for a particular product, and these are your predicted sales. Okay, so these are your predicted sales, these are actual sales of the test data, and you have made your model has made these predictions. So now we need to calculate how our model are performing. So first of all, if you see, the full form of MAP is mean absolute percentage error. If I talk about MSC, it is mean squared error. RMSC is root mean, or like it will be more of a copy of this one. So we'll just take the root of it. So it will be root mean squared error. MAE is mean absolute. You will not have percentage error. You will have mean Parul Puja. Okay, so that is great. Like I'm able to see. So error. Okay. Huge replies. Just give me a second. So okay, Bhuvi, you're correct. Sigma by root n. Okay. So in this case, the right answer is your error is basically your actual minus predicted. It is not predicted minus actual, it is always actual minus predicted. So your error is actual minus predicted. It is for every Rishabh. It's about MAPE, no, it's about MAE, MSc, RMSc. In every you do have a word known as E. E stands for error. So you need to calculate the error. So this is the error term and we will be calculating it. Okay, so you can press Alt and it will come down. Let me do some formatting for this. Alt H and central line. Alt H AC. Okay, so this is alignment I have. So your error will be how we will be going through this is I will show you first of all just focus here, see all the terminologies how the things are working. Then what you can do is you can just take some dummy data, like you can take 10, 20, 30 and just plus 10. So similar data you can take something like this 10, 20, 20, 10, some dummy data you can take, and then you can perform calculations of this error. Okay, that will be actually quite helpful and you can have a hands-on so that you are quite clear with this concept. Okay, how this MSc is calculated, you know, I know how MSc is calculated, how RMSc is calculated, how MAP is calculated, and I can do it even if I have these two values. So I don't require any function for the same. I can create my own function. So that is a level of confidence you should have, and that is will help you out during your interview phase and all, and during the practical implementation. Because actually if you see talk about MAP, there is no inbuilt function. sklearn do have a function to MSc, RMSc, MA, R square, but they don't have an inbuilt functionality for MAP. You need to yourself create a MAP function. So if I talk about error, it is actual minus predicted, that is equal to this minus, and this is how you, so for those who are not familiar with Excel also, it will help them in understanding Excel also. So it is your error is basically actual minus predicted. If you want to like do this one, press a equal to sign. So this actually says that you're starting a formula and it will be actual this minus this. So here the error is this. Or what I can do is actually I can take a insert a new cell here. What I will do is actually I will round them off, predicted cells, and I will use that one in order to make the calculation smoother. So I will use the round functionality, round, and I'll round this number to 0th digit, and I will use this. So I have rounded these off and I will use the rounded values in order to make the calculation smoother. And as you can see, actually it is a formula here. Round B2, it is a formula. So if I delete this row, for example, if I delete this row, you can see all the values become 0 because it was a formula linked. So I cannot do that. What if you want to delete this row, delete this column, you need to do is control, first select this column, do control C, and then do control alt and V. Control alt V, and then you can select values here and then press OK. So these are some of the shortcuts in Excel, and now we have only the formulas, values. All the formulas will be removed. So now I can delete this column from here. Delete. This column is removed, and here you have a reference error because that particular row is being deleted. So I need to just revisit the formula. That is this one is minus this one. Any doubt anyone of you have? If you have any doubt, you can write in the chat window. You can mute your mic and let me know the question. So is it clear till now? Till error? Okay. So this is how we calculate the error, that is actual minus predicted. Now what I want is, okay, great. First I will calculate MA. This is the most simplest one to calculate. So if you see this one, what your MAE stands for is, MAE stands for mean absolute percentage, mean absolute error. That is, we have calculated the error, we will do the absolute of it, and then we will calculate the mean of it. That is how we calculate MAE. And so this I can say is the value column. This is the metric. This is the full form. Okay. So this is a full form of it. And we'll do them bold. All touch BDA. Outline is done. So I will just find put the value here. So this is the error which we have. Now what I will do is I will do the absolute of error. Absolute, that is error absolute value. And it so this is how you can calculate it. This is, there is an inbuilt functionality ABS, return the absolute value of a number. So you can actually get the absolute value. And this is the absolute basically removes all, convert all the negative number to the positive one, and positive remains the positive. So this 0 remains a 0, and this is your positive values. So this is the one, that is error absolute value. So if I talk about MAE, I'm able to do two things. Error I've calculated, I will calculate the absolute value. Now I need to find out the mean. So I will calculate the mean of these absolute value. So that is my MAE will be. So what I will do, I will do is equal to average of what? I can do the average of this entire column, or I can do the average of these selected rows. So simply average. So if I talk about, this is my MAE. For this particular problem statement, my MAE value is 144. Any doubt anyone of you have while calculating this one? Yeah, understanding this one, how do we get this 144 value? I'm just repeating it. We have the actual values, actual sales values, we have to have the predicted sales. I calculated the error, that is actual minus predicted. This was the value which I had. Now what I've done is I have done the absolute of this error. That is we can do it using ABS in Excel. It is simply converting the negative to positive, just removing the negative sign, and these are the absolute value of the error, and then we have calculated the mean of it. So mean is 144. Now there is a question which I want to ask you. So to the audience, there will be a question which I'll be asking. So this question goes to Raghuram. Raghuram, while calculating MA, like if I talk about the absolute value, or if I see in MSc or MSc, there is a squared, we are doing the square of the error, or we are doing the absolute of the error. So in MAP, we are doing the absolute. In MA, we are doing the absolute. In MSc or MSc, we are doing the square. Why we are doing this? Like, what is the reason that we are doing the square? We are not doing the cube root, or we are taking the absolute. Why we don't do the mean of error directly? What is the reason behind taking the absolute value or the square of the error? Raghu. Raghuram, am I audible to you?
Yeah, I pinged you to get the positive value with it.
Okay.
So
Okay.
the value should not be negative. So we are doing the square to get the positive value.
Okay. If we don't do the square, or if we don't convert the error to positive, what is the impact we will get?
So the value will be negative, right?
Okay, a value can be negative. That is one of the case. But okay, if I'm happy with the negative value, is there any other impact which you feel? can be there. Correct, Bhuvi. So you can rest of the people can write the answer in the chat when privately pinging me. So apart from the negative, Raghu, do you have? Do you think is there another like
Get the
reason we?
best fit value.
Hmm?
To get the best fit value.
No, we are not doing the regression here. So like this is the output. So if you see MAPE do use absolute, they do the absolute of the error, whereas your MSC, RMSC do the square of it. They may do the quad of it, but they will not use a cube root. Why? Don't do square. When you will do the actually you Satish, when you will do the square, of course you will not get the absolute value, but all the negative value will be converted to positive. So square of -2 is 4. Yeah, Bhuvi, you can let me know the answer.
Yeah, when we do the square, we will get the absolute value. So that's the reason why we do the square.
No, by squaring you will not get the absolute value. So absolute is quite different. When you do the square, the values become positive. So our main focus is to convert the negative value to positive.
Gurdeep, we do this because if we have a negative values like -533 and in this column also have a -533, so we can actual minus predict it will like equal to 0. So we are using a square method.
Correct, Rishabh, quite close. So this is also the answer which I got from the other people too. So actually we are doing the absolute, or we are why we are doing the absolute of error. So we are actually doing the absolute, or you can say the square. Reason being your positive and negative will not cancel out each other. Okay, so for example, there is a negative value of -533. Suppose while calculating the mean, if you calculate them, so here you can see the formula, it is mean absolute error. So you need to calculate the mean of the absolute errors, not directly the mean of errors, because if you will calculate the mean of the errors, the negative will cancel out the positive values. So if I show you, for example, there is a positive 350, correct? I can say there is a positive 350 and there are two negative minus 180. So if you calculate the mean of these three values, so it will be close to 0. Correct, it will be close to 0 if you have two errors and one is negative, or I can say if your one error is -300, like your model was predicting below the actual. So -300 means your actual were below. So that is you are predicting higher. So if you have a error as -300, so your prediction values were higher, and in another case you have a error as 300. When you will calculate the mean of it, it will turn out to be 0. So in that case, if I do the average, so your actually it will say, you will take the mean, it will say there is no error altogether. It will say there is no error altogether. Actually there was error, but the error have cancelled out each other. So for example, if I take the mean of it, let me just show you, not the geometric mean, or I can say the average. So if I take the average of it, so it comes out to be -14. There can be, because it's more of a sample data, or a more of a sample data. So but when you do the prediction using linear regression, your mean will be 0 of the error, because it is basically a best fit line. So some value will be above the best fit line, some will be below the best fit line. In that case, if you simply do the mean of error, it will be 0. The mean of error will be 0. So that is the reason we are doing the absolute or square, because we don't want to cancel the negative errors with the positive errors. Because if that is done, as you can see, the error like came up to -14 is saying that there is very minimal error altogether, and that cannot be a case. That is why we are doing the absolute of it. So we get the MAE value as 144. Now what we will do is we will calculate the MSC, because after MSC we will be calculating the RMSC. So if I calculate the MSC, so what MSC require is error. We do have the error value, a square. So what I want to do, I need to do is square the error. So I can say square of error. I will do the square of it. So we can use the power function. So power will take the number that is error, and to tell which power you want to do it, I want to do a square of it. So this is my square of error, and MSC says find out the error. We have calculated the error. Do the square of the error. We have done this one too. Now do the mean. So I will do the average. Sorry. Average of this particular column. So the MSC in my case is 42889. It is 42889, and the RMSC, root means squared error, will be the root, or I can say the square root. That is, you need to use again the power formula, this comma 0.5. So this is your RMSC value. Any doubt anyone of you have till now? Please let me know. Rishabh, Satej, Baldev, Parul, Swati. Okay, yeah.
No, Gurdeep, it's clear for me.
Thank you, Rishabh. So this is how we calculate the RMSC, MA, and MSC. Now calculating the MAP. So now you will get to know why the client will prefer a MAP. So for example, you are the client, and if I say your MA is 144, correct? You will actually not get an understanding ki yaar my actual sales is 155. So it is saying MA is 144 units up and down, but for which values? For which values the what we say the error is up and down. So that is how your MAP will play a role. So if I do the MAP, it is error. Find out the error. So we do have the error. Calculate the percentage of error. Okay, so your error is actually how much percent of the actual value. So we need to find the percentage of it. So it will be so I need to calculate percentage error. So it will be, okay, it will be absolute percentage error. Like here it will be not mean, MAP will be coming here. So it is absolute. It will be a little percentage error. So what I will do, I will first of all calculate the percent. Error is what percent of the total value. So it will be actual minus predicted divided by actual. So how do we calculate the percentage change? So basically, I can say how do you calculate the percentage? That is, you calculate the error. That is how much percent your error is of actual. That is what I'm doing. So I'm calculating the error here in these two. I'm calculating the error, and I'm saying how much percentage your error, how much percent your error is of actual, and I will say into 100. So here, okay, sorry. I think here. Yeah, this is the percentage value only, or I can say I can remove the percent this from here. I will use the percentage of by default value. So this is minus 533, or so this is actually the percentage. What I will do is I will make this column as the percentage. So Alt H, and it will be P. So this is how much percent. So the percentage error is minus 53,300 percentage error. The error value is minus 53,300. Okay, and what I will do now, I will take the absolute of it. So here I will write ABS. That is absolute of the percentage error. So it is saying recommendation. So it is the absolute now. So you can say these are actually the percentage change. That is, if you see the difference, it is basically actual value was 1, the percentage sales is 534. So the error is 533, that is minus 533. So it will be minus 533 divided by 1. That is, the error is how much percentage of the actual value. It is 53,300 percentage of the actual value. So this is our absolute percentage error. So if I calculate the mean, so in order to calculate the MAP, that is, okay, so we do have the error here. We have calculated the absolute percentage error. So this is the absolute percentage error. Now we will calculate the mean of this. So it will be by average. So average and select this column. So our MAP in this case is 212%, and this is a very huge MAP. So what does this signify is 212%, or what I can do is I can just simply, I will change these values so that the values come to a limited thing. And so what I will do, I will actually plus 5. I am saying what I'm doing is intentionally, I'm keeping the change between the actual and the predicted as a difference of 5, so that the things will come under control. Okay, yeah. I will just cover that one too. Okay, let me cover that one first. So actually you see these are highly deviated by these. Okay, then I will cover one more concept, that is weighted MAP. To overcome this problem, we use the concept of weighted MAP. Okay, so you can see the MAP is 212%. So what does this mean is that if your actual sales is 1, your model can predict it up to 212%. Like it can predict it 212. So for actual value of 1, it can predict it as 212 also. Or I can say if MAP is 3%. So MAP of 3% means, so I think like from here you will get a better understanding. If the MAP of 3% means if your actual sales is 100 product. So if your actual sales is 100 product, like if your actual sales is 100, then your prediction can go. So if your actual sales is 100, then your prediction can go. Your prediction will be between 97 and 103. This is the meaning of MAP. If your MAP is 10%, then if your actual sales is 100, then your predicted values will be between 90 and 110. So it will, in this case, it was 97 and 103. So it is a question to all of you. If your MAP is 20%, so and if the actual sales is 100, your predicted value will be between which two values?
120 or 80.
Correct. It will be between 80-120. So these are smaller values, correct? So these are smaller, so great answer from all of you. So these are smaller values, but think of a case if the sales is 1 lakh. Okay, if the actual sales was 1 lakh, and if your model is having a MAP of 20%, and the client accepted it, so the actual sales were 1 lakh. So your model will be predicting the values between the. So basically, this is the error in the model. So it is 20%. So the prediction will be between 80,000 and 1,20,000. So the model can say the sales as 1,20,000, and actually it can be at 1 lakh. Or the model can say the sales as 80,000, can predict the sales as 80,000, and actually it would be at 1 lakh. So that is where the risk will be. That is 20,000 product. So if it over predict, that is, if it over predict, that is it predicted 1,20,000, then the company have to will be left up with 20,000 extra products. For example, in the case of, you can say, chocolates, if it is more of your like the Christmas week, and the prediction from the model was like it was having a 20% MAP. So it was having a 20% MAP, and like the model said that okay, the sales will be 1,20,000 chocolates, and actually it was 1 lakh. So the company will be left with 20,000 extra chocolates, and it will be paying for its inventory cost. They have to store those 20,000 chocolates. It will be paying for the inventory cost. Okay, that is warehousing. And the second thing will be each chocolate will be having an expiry date. Then, like if it is 3 months, then they need to sell those 20,000 chocolate within a span of 3 months, else they will expire. So they will be giving some discount altogether, and that is actually will be a loss to the company. That is why they want the prediction to be more accurate. Okay, so and think of okay, so it was overproduction, and if by chance the company produced like if the actual sales were 1 lakh only, but the model said the sales would be 80,000. In that case, again it is a loss to the company, because there was a capacity of 20,000 chocolates which from which the company can earn the revenue. Okay, can earn the revenue. And if you see there was a window of 20,000 like from where the company can earn the revenue, and that is, there is actually another loss. So if I ask the company that okay, they would prefer a overstocking or understocking, I would say a company would say okay, from the actual value you can please give the prediction above, because when you give a prediction below, like actual sales were 1 lakh but you predicted 80,000, actually there the company loses the customers too, and that will be a loyalty change. For example, you went to the shop and you said okay, do you have a Cadbury chocolate, and the shopkeeper said okay, I don't have one, you can try the Kit Kat one. So it might be that from going forward the customer might switch to a competitor, and that is actually a revenue loss plus a customer loss, and that is a more bigger loss as compared to the inventory cost. That is the understanding business context of these things. So with the map, the client will be able to clearly identify okay what the error can be. Okay, so I have
Hello,
a
Gurdeep.
request.
Hello,
Yes.
Gurdeep.
Yes.
Can you please explain the absolute percentage error once again, the column, how we calculated it?
Sure, I will just calculate it. I will just let you know again. So the formula for this is, I will just write in the, okay, I will actually write in the formula here also, and I will show you again. So if I tell you how to calculate this is basically your actual minus predicted divide by the actual, and you multiply the complete values by 100, and then you take the absolute of it. So this is what I have done here, and I will show you the implementation too. So this is what we have done, that is this one. So let me show you again what I did here. So in this case, if you, so I can show you the formula. So when you click F2, it will let you know. So in this, you can see what I have done is, this was my actual. So this is the actual I have. So actual minus predicted. So I did 1 minus 534. So this was the error basically. Divide by the actual. That is, I'm identifying what percentage the error is of my actual value. So I calculate the error, I identify how much percentage the error is of actual. Okay, so it is actual minus predicted, that is error, divide by the actual value. I divide by the actual value, and this is my percentage error, that is how much percentage the error is of actual, and then I calculate the absolute of it, and that I got the value as 53300. And then here I'm calculating, so I just have put the formula to the complete rows. So you can see it is this formula is implemented everywhere. A3 minus B3 divided by A3. A3 actually is referring to the cell number and taking the absolute of it. So it is 8,000. So you can see here and here I'm calculating the mean of it. That is average of column F. So Swati and Yash, is it clear? Yes. Do I have to do I explain again?
Yes, it's clear.
Gurdeep, I have a question here. By predicting the MAP, we are trying to understand how good the model is, right?
Yeah, we are trying to identify how our, so basically what percentage of error our model do have.
Correct. So basically, the lower the value, the closer the value MAP value is to 0, the better the predictive model is, right?
Correct.
So
So no,
and
sorry.
so the companies would go ahead and depending on the predictions that we have, the companies would approximately let's say a manufacturing company would manufacture around plus minus of the figure that we are predicting.
Correct. So it will be more of, you can say, basically you have a MAP of 2, 3, like 4%. So
Right.
what the company will do, you make a prediction of, you can say, you made a prediction like, for example, 1,20,000, like 1,04,000. Then they will get an understanding that the actual value will be around 1 lakh. It can be between, so this is the window gap which we have. So they will be identifying the window rate. Basically the error is 4%. If the MAP is 4%, basically they are saying the error is 4%. And if the prediction is 1,04,000, so the actual value will be around, you can say 1 lakh. It can be basically, it will be between 1 lakh to basically 4% less of 1,04,000, 4% above of you can say.
तो हम ये बता रहे हैं कि हमारी प्रेडिक्शन ये बोल रही है कि आपकी जो एक्चुअल सेल रहेगी वो 80 से लेकर 120 के बीच में कहीं पे भी हो सकती है, is what we are telling the company, right?
Correct. अगर वो मेप 20% है तो अगर आपकी मेप 4% है, let me just show you, अगर आपकी मेप 4% है, ठीक है, if it is 4% and your actual sales is, you can say 1 lakh, ठीक है,
data वार्तन
if your actual sales is 1 lakh, I say like I write 1 lakh here, तो आपकी जो actual value, so this is your prediction. Okay, sorry, let me re-emphasize. So if your MAP is 4% and if your MAP is 4% and if your predicted sales is, what your model predicted is 1 lakh, so your actual sales will be, yeah, I think Satej, your mic is on. Okay, so your actual sales will be between is equal to, you can say 96%, that is 0.96 into this, that is 4% less. So your actual sales will be between 96,000 and it will be, so you will say 1.04, that is 4% below and 4% above the actual value. So it will be 1.04 into, just hold a second. Okay, sorry, it will not be this one. So it will be, actually you do have a formula that 96% of X is, okay, it is 96% of X. So actual sales in this case can be 96% of X is basically 1 lakh. So it will be 1 lakh divided by 0.96. So actual sales can be 1,04,000 or the actual sales can be this divided by 1.04. Just give me a second. Yeah. So it is saying if your prediction is 1 lakh, then your actual sales can be either 1,04,000 or it will be 96,000. This is the window you will get.
फेस्टिव टाइमिंग एंड और सीजनल टाइमिंग, जब हमारी सेल्स सबसे ज्यादा ऊंची भी हो सकती है और नीचे भी हो सकती है,
करेक्ट,
तो एट दैट टाइम मेक वैल्यूज को हम उसी तरीके से लेंगे या फिर ना मदद करनी?
कैन यू प्लीज रिपीट योर क्वेश्चन हरमीत?
सर जैसे कि फेस्टिव टाइमिंग होती है, ये तो नॉर्मल हो गया, ठीक है सर, अगर जैसे कि फेस्टिव टाइमिंग होती है या फिर सीजनल टाइमिंग होती है, तो उस टाइम पर हम लोग अलग से वैल्यूज को करेंगे या फिर
Okay. So good question. So actually, pata hai, what it is. So normally, what we have is we don't create specific model considering the festive season. So it depends upon what type of model you are creating. So if you have created a specific model for the festive season, तो आप festive season वाला map use करोगे. And after the festive season, if you have a normal model, तो आप उस वाला map consider. So normally हम क्या करते हैं? We normally create a single model for the entire year. तो जो map की value है, it will remain same throughout the year, whether in festive season or non-festive season. And if so, it can be another scenario that if you have created a specific model for the month of festive season, for example, मैं आपको बताऊं, तो आपने एक दिसंबर के लिए एक मॉडल बनाया, दिसंबर में फेस्टिव सीजन है, एंड एक मॉडल आपने बनाया जैन के लिए. So दिसंबर के लिए it was festive season, you got the MAP of 3%. Okay. So दिसंबर के जो पीरियड के लिए आप 3% का MAP यूज करोगे, एंड जैन के लिए जो आपने अलग से मॉडल बनाया है, and you got a MAP of 7%, or not 7, like 5%. So in that case, you will consider the MAP of 5%. But holistically, हम पूरे साल के लिए एक ही मॉडल बनाते हैं. We don't create model different for different months, because main thing is कि at a month level you will not have that much amount of data. 30 days का data होगा. So we create a model at a holistic complete year level. Satyaj, yes, before creating models, you need to remove the outliers. You need to fill the missing values. Every EDA will be done before. EDA or data prep will be done before. Yeah, Bhuvi.
So that yeah.
Gurdeep, you had mentioned that after 6 months we go back and do the predictions once again, right? Look at the models once again.
Correct.
So in that case, the MAP can be a different value, but here you are saying that we do it for a prediction for the entire year. How
Okay.
does that work?
So if I talk about after every 6 months, 5 to 6 months, normally you refresh the model. Okay, refresh the model means you will, because like and normally see that is basically a model refresh. For example, you created a model for the entire year. For example, this is Feb 2021, and today I created a model, and what I will do is the client will give me the data, like for example, it is more of a churning model. He will give me the data for the month of March. Okay, April, May, June. So with each month, in the starting of the month, they will give me the data, and I will make the predictions over them. So what will happen is, so the model, okay, or if I talk about the sales data only, so sales data normally we create for the entire, it is not for the year altogether, it is on the complete data. For example, if I talk about, if I'm creating a sales data, and the sales data will be, I do have the data from 2015 to 2020 at present. Correct. What I will do is, I will use the data from 2015 to 2019 for my training period, and 2020 will be the testing phase. So it will be training here, it will be testing here. So if I talk about, so this actually model is not built at a yearly level, first of all. So that was a point like I want to make. So it is not at a yearly level. So in now you can provide any data 2021 to 2022. You can give a complete year data also. You can just make the prediction directly. So the window which I was saying that it is a yearly model. So that is normally we have in the time series type, that when you need to make the prediction for the next quarter. Those are specifically to time series. But if I talk about in a single regression part, that if you have these data from 2015 to 20, this is the total data. So this is the total data. Out of this, we will use this amount of data for training, this amount for testing, and then you can actually training testing means with testing you will identify what is the accuracy or what is the errors of the model, what is the MAP we have for this particular model, and then what you will do is you will get the Jan 2021 data. To Jan 2021, you will get this data. You will get the Feb 2021 data. So you will keep on getting these data. Like if I say, like These are the data values you will get Jan 2021. So you will use actually this model only. So you have created a model here. So you will use this data only. Sorry, this model only to make predictions on this, this. So you will use this model only. So how actually it will impact is the map. So while building this training data, you saw the map on the testing was 2%. Okay, so you made this model here and you tested on this testing data, that is 2020 complete year you tested, and the MAP was 2%. Now you got the data for Jan 2021 and you made a prediction over it. Here also you saw the MAP is 2%. Okay, here you saw the MAP was 2.5%. Here again it came out to be 2%. It might be that there might be some deviation, some noise in the data which your model was not able to predict, and the MAP went high. Now you see that here again the MAP went to 2.5%. So there are some deviations coming into the data which you are getting, or some new things are happening. Here it goes to 3%. Here it went to 3.5%. So now what you're saying is actually the model which you have created, I can say here it can be again 2% because it will walk up to here, but here it went to 3, it went to 3.5 again, 3.5%. It went to 4%. So now you see the trend that, okay, when I created the model from 2015 to 19, this was the training data I used. This is the testing data which I have tried, and the testing MAP was 2%. And so this is known as testing data, and this is known as out of bound data. These are known as out of bound. That is a completely new data you have. So this is the out of bound data you have, and this completely is out of bound data. So you made the predictions on January 2021. You make the prediction to February 2021, March 2021, April 2021, and these are the MAP values you are getting. So these maps are quite close to the testing map. But now going forward, actually your MAP values are increasing. Here it came to be 5%. So then you will have a meeting with your managers or the leadership, and they are saying that this actually model is not performing well. So what you will do is in October, I can say in October 2021, you will again work on creating a new model which will ingest the data from 2000, you can say 16 to 2020. It will use, or you can say 2020 you will use for training phase, and you will use 2021 data for testing phase. And then you will create again a new model, and you will check, okay, the MAP is 2%, and then you will use that model for future predictions. And then again, because you can see that time window is also moving now, because it might be that 2015 data was not relevant, it was out of trend that time, and now the things have changed. There is more e-commerce coming in now. That time it was not that too much. So you will move in the data to a window of, you can say, 4 years. The complete year you can use for prediction then, and that is your MAP can be. You will calculate the MAP. So this is what I meant by refreshing a model. So you made a model till 2020, you predicted it upon, you can say, the 6 to 7 months, and then you see that your model is not performing well, then you're creating a new model here. So this is known as model refresh. So you normally do the model refresh. So it depends upon the data. For example, the banking data does not change a lot. But if I talk about the telecom industry, the data changes a lot. Like it might be that you need to do a model refresh within a 3 to 4 month cycle, because there are huge competitors and they're coming it with very regressive marketing initiatives or marketing strategies with highly discount and all. So in e-commerce also you need to, like, you may be that you refresh the model in 3 to 4 month cycle.
Got
is
it.
it clear?
Got it. Gurdeep. Gurdeep, I have one more question here. Let's say, for example, there are a new situation. Like, for example, I'm predicting the attrition of a company, and there is a new situation like COVID, which is coming in. Obviously, my old model will definitely not work because there is a new situation here. So, we do generally people wait for refreshing the data and all of those, or do they go back and ask the company to rework on the data once again? I mean, creating a new fresh model.
Okay, I got your point. So actually, I normally take an example of Airtel working out here. So for example, think of a scenario that like I think Geo was launched in 2018 altogether, I think. So like when the Geo launched, it gave the service for free. So that is the best example I say how a competitor, you can say, crushes the other competitors. So like Airtel was having a monopoly in everything, like in the data field, like the data was coming like 600 rupees for 2 GB and 3 GB, 3 GB amount of data. Geo came in, so like the Airtel guys, the Airtel company would be having some model altogether, finding the prediction. Okay, this much amount of recharge will be this much customers we are going to gain up. Correct. But next month Geo came in, and it gave everything for free. All the models of Airtel will go in vain. They will go in dustbin, and they will have to create new models, keeping a new competitor into consideration. That is how it will work. If I talk about the COVID scenario, till March 2020, everything was going very good. The hospital, for example, the hospitality sector, if I talk about, they were saying so it was overall stats which I like went through. So they said that the hospitality sector will grow at a rate of 40% this year in 2020. It was a report in Jan 2020 that the hospitality sector, or you can say the hotel industry, will grow by a rate of 40%. But in March 2020, there was a lockdown, and the complete models which said that the growth will be 40% will collapse, and they need to create a new model, considering creating a new, taking a new feature. So that in that case, the new model will be created by incorporating the latest feature, that is COVID flag. They will have to mention, okay, now the sales is 50. Earlier the sales were earlier the number of rooms booked were 50, now it is 2. And you will incorporate a new feature or independent variable with the name COVID, and it will be similar to like this. So you will, so the feature would be like this: COVID flag. So flag means, so I say this is the price, and if I take the dates, so date was like uh, first, I can say 1st Jan, 2nd Jan, and similar to like this, the price of the rooms were, you can say, 100. Okay, and room, so I can create a new column here, that is rooms booked. So earlier you were not having this particular column, so I can just hide this column for at present. So this was the data points you were using. Okay, the price went to 2000, so rooms booked were 20. Then it, in this case, it was like 15. Similar to like this. So you will have this data till March, like 1st March, I can say the room price was 100, and again the booking were 25. But when the lockdown started, 23rd March, you will say the room price was 80, but number of room books were 1. So here the model will become mad. He will say when the price was 100, the room booking were 20, but now the price is below, it is 80, and the room books are the booking is 1 altogether. So how can this happen? So model will not be able to identify this scenario. In that case, so this is a previous model you were building. Okay, so in that case, you need to refresh the model. As a refresh model, because this model will go in vain, the model will not be able to identify. Or I can say here, I can include a one more factor, that is discount. I can incorporate one core column here, discount, and I say the discounted time was 10%. Here it was 20. 10%. Here it was 20. Sorry, 20%. And similarly here also it was 10%. And then also here it is also 10%. So if you see this model, it will say the price is below this scenario, and the discount is equivalent, but then also the room books are 1. So your this model will not be able to identify. This model will not work. This is a COVID situation I'm talking about. In that case, what you do is you will restructure your data, and what you will do is during the model creation, you will create a new flag, which is the COVID flag. So you will say COVID. Here the COVID was not present, 0000. Yeah, here the COVID was present. Then the machine will be able to identify, okay, this particular event, this particular feature occurred, and then that is why I have a booking of 1. So this is how you will create your models. This is how, so basically that model is not refresh, this is a recreation of the model, the complete exercise. So in refresh, normally what you do, you normally change the time window. So here it was a refresh, that okay, you change the time window, you create the model again. But in this case, it is not a refresh, it is the what do we say, it is like making the complete models again, making the data prep again. So it is a recreation of models, not a refresh. And you need to like create everything again. Yeah, so this is the COVID flag which you need to take. So Bhuvi, did I answer you out? And I would request one thing from all of you. I would request you try asking me these questions, because everything like I might not cover up, but like if you ask this business specific questions, then I will be like help you answer with that part, because that I can like bring in those things and I can let you know, okay, these things happen. Because in normal like letting you the like we were covering a matrix for regression, and I might not cover these that much in detail. But if you ask me questions specific to this, then I will go in the in depth of these. Because yeah,
I want to ask you about the Royal Enfield. Actually, Royal Enfield introduced 2 new products under the span of 6 months only. So,
correct.
what is the tact and what is the data modeling they can be explained? Lightly, can you discuss about that?
Okay, so you want to say that okay, if Royal Enfield having incorporated 2 new bikes within a span of 6 months,
Yeah.
so how it is going to what the sales will be for
Data
that product?
modeling on that, yeah.
Okay, so in that case, actually, see, when you talk about the companies create separate model for separate products. Okay, so for example, in Royal Enfield, you have a model for your 350. I can say you have a separate model for your classic.
Yes.
Okay, classic 350, you will have separate model that is considering all the sales for it. You will have a separate model for your Thunderstorm. You will have a separate model for your Electra. So there will be separate models altogether. So if 2 new models are incorporated, of course. So if I talk about classic 350, if you're creating a model for it, so how the features and data points will be looking like. So I can say the year for which you're considering the sales. So it will be year. It will be the month. It will be your competitor price. So if I talk about Royal Enfield, you need to see the category also. See, actually, if I talk about Royal Enfield, Splendor, Hero, your Bajaj, they are not the competitor. Royal Enfield is a field altogether. For them, the competitor would be some bike similar to them, such as Indian is one of the company which is a competitor to them. Or you can say there is a new company like Fiza or like something like that which has entered the market again. So those are some of the classic, like actually the competitor can be like Harley can also not be a competitor because they are very high pricing bikes. So in this case the competitor price, okay, for example, and it will be your price, okay, your discount, how much discount you're giving, and your distribution and your marketing. So what it will do, and there is a concept of cannibalization. Okay, so and here you can create a flag of your own product. Your own product price means, for example, if I say, if you want to say see the sales of your classic 350, then for classic 350 within your product range, the competitor can be a standard 350 or Electra 350. So those who are familiar with the bike or all this, so for like whether person do have option of either buying a classic 350 or they can buy a Electra 350. So the price are quite similar, correct? So when they will launch a new product altogether, and there is a concept of cannibalization, that is sometimes companies launch their products at a very frequent range, like Samsung Note 9, Note 20. So what is actually happening is some of the products will switch. So they will get some new customer. They will get some new customer, but those actual customers are not new. Earlier, those customers were using the other product of their same company. For example, uh, like Classic 350 is one of the bike of your Royal Enfield, and the other bike they have launched is, for example, I say XYZ. So earlier the number of users for Classic 350 were 100. And when they launched this bike XYZ, that is, its name can be anything. So it got 20 new customers. But actually those 20 new customers were the customers. So like those 20 are the customers which shifted from Classic 350 to XYZ. So now the new customer for Classic 350 are 80 only because 20 shifted to this new bike. So this concept is known as cannibalization. That is one product of the company is eating the other product. And that is what companies don't prefer. Actually, what they want is they should eat the customer of their competitors. That is what the Bullet will want is, what the Royal Enfield will want is that they bring in the customers who are using Bajaj at present, and they should switch those to the Royal Enfield and not inter movement. That is, they don't want that okay, people who are using Classic 350 will start buying XYZ, because actually it is a loss to the company. There this particular product will decrease its sales. So when you create a model for the new bikes launched, you will take all these flags into consideration. Harmeet, any more doubt anyone of you have?
Yeah. Does listing of a company or an organization on a IPO or on a stock market impact on data modeling?
See, I would say that is more of your this is
Like
this question
Nykaa will going to launch an IPO. Okay. So that impacts our data modeling.
So actually that will you can include that part too. Okay, so like if I talk about so their question is, will Nykaa IPO impact the data modeling part? My question to you is, does Nykaa going to IPO impact its sales? Like for example, Burger King. Let's take the example of Burger King. Nykaa is more of a beauty product. So if I take an example of Burger King, Burger King was present earlier also, and you do have its sales number. Now tell me one thing: Burger King launched its IPO recently. So does Burger King launching its IPO will impact its sale, Harmeet?
No, I don't think so.
So if it will not impact, then that flag will not come in the modeling. If your IPO coming to IPO impact the sales, then you will incorporate that factor into
But sometimes
the part.
brands create the sales. Sometimes branding also have this, like in a brand, like in a company listed on IPO or listed on stock price. That's brand.
There is one thing. I think that it involves some economics too altogether. A company who is coming into IPO will have its existence from decades, correct? So it will have its name established altogether. Tomorrow you open a company and day after tomorrow you go for IPO. Actually, nothing will happen. So by going into IPO, your sales is not being impacted. No one will buy the share. First you create a brand, then you go for the IPO. So actually going to IPO will not impact your sales. It might impact your sales in one way, because when a company go for IPO and when the people buy those shares, so the company do get some funds. Okay. So earlier, like normally companies go to IPO because when they are shortage of money. For example, Burger King, they were having 100 crore rupees. So what they did, they released their share for public in IPO format. And from selling to their IPO, they got 2000 crore extra. So earlier they were having 100 crore, now they got 2000 crore. And so in total, they have 2100 crore rupees as a reserve. So what they will do using that money, either they will do they will be aggressive on the marketing activities, or they will be aggressive or expansion. Okay. So you will actually not incorporate the IPO flag, but you will incorporate your marketing strategy flag. Okay, of course, going to IPO will lead to having more aggressive marketing activities or doing expansion of the business altogether. So those are the flags you can incorporate. But if you're going to IPO, if you're not changing any past strategy, such as you're not doing any marketing now, also you're not expanding, it is not going to impact. There will be an indirect impact.
So does economics play a part in this, like you said? So for example, hello Gurdeep.
Yeah, sure, audible.
So for example, like right now the scenario is that there is a bird flu, okay? So will that impact the sales because the raw materials that the Burger King uses is chicken? So in that case, economics play a important role, right? In case of determining sales.
See, okay, correct. So see, if I talk about bird flu, see, okay, if when I talk about the economics concept, now economics, I normally mean your GDP. And normally, actually, when you create these models at a higher scale, you involve macro. So there would be some guys from in the economics field altogether. So there is a concept of macroeconomic factor. So there are two: microeconomic, macroeconomic. So macroeconomic factors include GDP, inflation rate, your wholesale price index, retail price index, unemployment rate, uh, employment rate, and all these factors. So these are the macroeconomic factor. While creating these models, you of course incorporate these. If I talk about the bird flu, it is quite similar to your event like COVID. Bird flu actually, so there are some industries who use chicken, correct? Like KFC, I can talk about. So KFC, huge business in the non-veg sector. They use chicken as a huge raw material. So if there is a bird flu, it will impact the KFC business and it will not impact much of the McD business altogether, or it will not impact the Sagar Ratana because they are not using chicken altogether. So actually it depends upon whether, so you need to identify whether the raw material of a company, of a business is impacted, then those particular business will incorporate that flag. So of course, bird flu will impact the sales of the business who are using chicken as a raw material, and they need to incorporate this flag because people will avoid eating chicken and the sales of KFC and all this will go down, and they need to incorporate a flag. So these are the seasonalities. Of course, that is why I'm saying that you require a model refresh altogether. You need to tell the model, okay, the sales went down because of this particular thing. That is, it will try to learn the behavior from the same. So Yash, did I answer your question?
Yeah, Gurdeep, that's fine.
Oh, okay, welcome. Any more question anyone of you have? So like good
Gurdeep,
questions.
I have a question.
Yes, please.
So, with our common understanding, or say common sense rather, can we assume some, some situations like COVID and bird flu and build a model, or for every variable that we are considering, or for every data category that we are considering, we require the client's consent? How do you do it actually in the industry while you are actually working on a project?
Okay, so good question altogether. So actually, Pooja, you need to take the sign off from the client on each and everything. So see, actually, client will come up to you. They will say, okay, like you need to give us the prediction. Okay, you need to give the prediction to us, and this is our data, past data, and all this. We are not in the analytics field. So what you will do, actually, you will understand their data. You will understand their business. Okay, their business raw material is the crude oil, or their business raw material is basically your chicken industry, you can say, or yeah, you can say meat is the raw material. So you will understand their data. Actually, the company, a business do analytics companies do read their annual reports. They actually will understand their business first of all. That is what things are impacting their business. They will read their financial report. Did they get any funding or not? Like whether their competitors are getting any funding or not. So they will understand the business of the customer first, client first, and then we will say these things are impacting your business. Please give a sign of that whether you are impacted by this particular. So you will go to the client, and actually you will have a client meeting like once a week or twice a week in the initial phases, during the data discussion, during the EDA phase, and you will come up with some assumptions. Okay, this is our assumption that you are being impacted by this particular competitor on a larger scale, or whether this is a competitor for you or not. Okay, so that is the questions we ask from the client. Then we say, okay, your business is impacted by COVID. Should we include COVID in your flag or not? So they will say, okay, like of course you need to take the sign off from the client for each and everything, because main thing is you are taking money from the client. Okay, and you are providing a service to them. So for example, you use the COVID flag, and at last doing the model delivery, you got a very good map altogether, and you like got a very less map. The model is very good, and at last when it came to the delivery phase, the clients will say, okay, I actually don't want to use the COVID flag altogether. From where I will get the data for it in the near future? From where I will get this? From where I will get this? And I cannot take this model altogether. So you please create a new model for me, and I will not release your price. Okay, and actually it is an unfavorable situation for both the client and the analytics firm. And that is why we have a habit of taking sign off on each and everything. Even a single pen we move, we will tell to the client, okay, this is what we are doing. Because we don't want an unfavorable situation at the end. Okay, that client said that we actually didn't want this thing and you created this one. So Pooja, did I answer you?
Absolutely. Thank you.
You're welcome. Any more question from anyone? So huge number of business questions, like good discussing these things. So yeah, recently LIC announced IPO. Yeah, correct. So these actually will impact the competitors overall. And actually, like why IPO, the companies try to like gain money from the market, and then they will use that money for their marketing or the expansion and everything like that. Those are the plans. So any question, or we can like any more question, please let me know. You can write in the chat window, or else I will start with the so this is what we have. These are the regression matrix we have, and so okay, now we will move to the next metric, which is your just give me a second.
Gurdeep, can you show the formula for the each matrix? So just want to note it, or you wish?
Sorry.
So for each metric, can you show the formulas, please? To take the notes.
Actually, I will share this Excel file with you, complete one.
Okay.
Yeah, I will be sharing this Excel file with you on which I'm working. So yeah. And one thing what we can do is, if you want, you can actually open an Excel file. If you want to do some hands-on on this, you can just make 5 to 10 rows on it, and then you can do it.
That's what I'm doing. So if we have that formula, then
okay. So actually the formulas are incorporated in it only. That is why. Yeah, okay. Just let me show you. So this is okay. There was a concept of weighted map also. Okay, just give me a second. Okay, so you can see here. So we have calculated our map, MSC, RMSC, and let me just delete these rows. Okay, like these rows are of data, so I will not delete them up. I will just minimize their size. Okay, so as you can see, the R square here now. So actually, like this Raghu, like the main concept for like on which I'm discussing is, so that is what I want from you, that you can derive actually the formula from the definition itself. So in this case, if I talk about the formula for MSC, it will be, that is mean squared error. So this is one of the recommendation I will do whenever implementing this. The formula will be read it from the reverse order. MSC, like mean squared error, what you need to do is calculate the error first, that is actual minus predicted, do the square of it, that is which we have done, and then calculate the mean. If I talk about MAP, calculate the error, calculate the percentage error, or I can say calculate error, and identify the percentage change with actual, do the absolute of it, and then calculate mean. If I talk about R square, so in this I can say I can actually change the predicted value. So in this the MAP is coming 212%. And there is one more question which I have. So if you see MSc and MAE, okay, let me show you. So what I will do is I will actually take this value and plus 5 in it. So I'm by this actually things will come under control. So you can see the actual was 1, predicted sales became 6. Actual same or okay, let me tell you a concept of weighted map then. Sorry for this. So anyone, what do you mean by weighted map? Any idea, anyone of you, what do you mean by weighted map? So actually what weighted map stands for is we calculate the weightage. Okay, so we see here the map is 212%. So what so if you see here, okay, so if you see here, let me give you another example. Think of a case, or I can paste this data below, like it is coming in between. So it will be below. No. Okay, so what I will do now is just to make you clear about the weighted map concept. So if you see here, there is a scenario I will just show in front of you. So this is weighted map concept, and I will just explain you what do you mean by weighted map and all. So think of a case, your actual sales is 1. So and I will let you know why we actually have to use weighted map. This is the actual sales, this is the predicted sales. So your actual sales is 1, your predicted sales is 60. Here your actual sales come out to be 1000 and your predicted sales is again 1060. So if I calculate the error, here the error is 60 and here again the error is 60. So it will be again, so it will be 60, it will be absolute error, I can say. The error, it is the absolute error. So this is a question to all of you. What will be the map in the first case? What will be the map here? And what will be the map here? Do write in the chat window. So what will be the map in the first case? What will be the map in the second case? Okay, Raghu. What I normally feel is that students do see answer. That is why I say to ping in direct. Okay, that if any student answer it out, so like people get influenced by it. Okay, so Parul, how the map is 60? Please let me know.
The square, hello.
Yeah, Parul, you're audible.
Square of this is 120.
Square, okay, but map, if you see the formula,
yeah,
we are not doing square.
mean square error. Mean square is 120 divisible by 2. Is equals
Correct, but actually I'm asking map. I'm asking value of map. So here I'm asking map. So it will mean absolute percentage error.
Yes, yes.
Here the error is 59, sorry. And here the error is 60. So what will be the map in the first case? What will be the map in the second case? And how your map is 60?
Now,
Raghu, how your map is 60 in this case?
60.
What I consider this absolute to everybody, but it's wrong. We cannot consider like this. So is it? So we need to do all these things, right? Error, absolute value, square of errors, and then we need to calculate the absolute percentage error. So for first, I'll get the 5,900 as absolute percentage error.
Correct.
Okay, so second one I'm getting as a 94. Correct.
You are getting a map of 94 here.
No, not map. Absolute percentage error, I'm getting 94.
Okay.
So
You will
then
not
we
get
need to take the
absolute,
mean, right?
okay.
I'm talking about the absolute error. Absolute percentage error.
So in this case, what will be the absolute percentage error?
So it's 94.
It will be 6. So how it will be? Absolute percentage error basically is your percentage
Okay, 1
of
minute.
error.
I put wrong one. 1 minute, I'll check. 1 minute. Yeah, it's 6%, exactly. 6%.
Okay. So it is 6 here, and
Okay,
it is
then we-
5,009. Yeah.
Okay. So we need to take the mean of this too?
No, okay, yeah, you can take the mean of these two for sure. Like for example, if I take the, yeah, you will be taking the mean of these. So that will be your complete map.
Okay.
So in this, the map comes out to be 2953.
Exactly.
So this is a request. Please don't copy others' question. Okay. So yeah, Pooja, you.
But I
It
did
is
not
correct.
copy that, sir.
Okay, sorry. But yeah. Okay, no issue. Sorry for that. But yeah, I would say that's a request you all to please ping in private. Ping the answer in private. Actually, you don't copy, but what I see is students get influence. They will do simple
Gurdeep, one more
calculation.
question, Gurdeep.
Yeah.
So company will have any preference? For example, if you go for data science, whether company will have any preference to write the coding in R or Python? For example, we heard about that SAS means it will give a more secure, and it will give more accurate data. So will company have any preference, or we can write it in any one of the? So if we strong in any one language, is it fine, or we should have the knowledge in both R as well as Python,
Okay.
SAS, etc.?
Okay, so if I talk about the SAS, so there are 3 languages: Python, R, SAS. SAS, if I talk about, of course, like the data is encrypted, but no company will use that. Normally, the startups will not use that. Only the banking client will use that, because SAS is not open source. You need to buy a license for the same, and that license would cost like 4 to 5 lakh, I think, for single license to the company. So there is a cost associated with it, and companies are thinking to reduce the operation cost. They can do the same thing using Python R, so they will not pay for it. Only banking client normally use the SAS. That is the first thing. Regarding will the company have some preferences? I would say company don't do have a preferences. Normally the analytics team will have a preference altogether. So because they will see what most of the team is comfortable with. Okay. So of course it will be open hand to you. Okay, you want to do whether in Python or R. So you will have a preference from Python R, not from the SAS perspective, because company don't have a SAS license altogether, then you cannot use SAS there. Regarding Python R, of course, you can get a leverage, but if it is more of a code accumulation, for example, if you are given a part of data prep, other person is working on the modeling code, and if the other team is working on Python, then of course they will ask you also to work on Python. Or if the team is working on R, they will ask you to code on R. That is, I think I gave this answer in the starting, that I would say be familiar with any of the one of the languages. Be familiar with all the languages, that is SAS, Python, R. Do learn the basics, do learn the basic code functionality, and do learn those and gain expertise in one of the language, either Python or R, I would say.
Will it give the both Python as R will give the same model, same what accuracy, or will it vary?
It may vary. That is the first thing, because actually, if you see the libraries, like in Python, we're using SQL, and in R, we would be using another one. So those are being developed by some individual developers. So they are not the same. So their formula may differ at the backend. Or you can try the random seed variable, random state, I can say, by which you will get the accuracy correct. Then you can get the same accuracy altogether. So regarding the preference, company does. Nowadays, company don't prefer much of SAS. Of course, banking client does because they require the encryption of the data. Otherwise, people like companies, the startups or the other companies prefer Python and R. And if I talk about Python, so you can do a search over the Google at okay, which language is more preferred. So I would say Python is more preferred because it do support the NLP and the deep learning libraries, whereas R does not support them. Python support web scraping, R does not support it. So Python is at a leverage as compared to R. This is my understanding. But I would say be familiar with all the languages and try expertising in one in the first go. After, like when you're expert in, for example, try being expert in Python, and when you're expert in Python, then you can become an expert in R. Don't try both the things at a single go because it will be a little complicated. You will get confused and you will not be expert in any of those then. So in this case, the overall map is 2953, correct? But if I see the scenario, is it true? Is it correct? I think like the things are quite biased in this case. Actually, the difference, like for example, here the actual sales was 1 and here it was 1000. The predicted sales was 60, here it was 1060. Or I can say it was 61 here. Then the error will be your 60. And the map will be 6000. So I think the map is highly biased toward the larger gaps. Okay, so in this absolute array is 60 and your map is 6000 and your map is 6 here. So if I do the average of it, so your overall map comes out to be 3000. But I think that is not actually the case. Only a deviation of 59, a deviation of 59 elements, 59 products should not say that the model is very bad. In that case, I will use the weighted map concept. So weighted map, what it does is it gives the weightage. So actually it will find out what is the weightage of the actual sale. So it will say weightage of, so it will identify the weight, sorry, it will identify the weightage of your actual sales. So that is what you will do is you will divide the actual sale by the sum of all the sales. So here the weightage of this particular sale is only equivalent to a 0. So the formula is you will divide the sale by the sum of all the sales. I think like it is actually have moved the formula down. I need to freeze these rows. So I'll be freezing them using F4 key. Sorry. I will use F4. Okay, sorry, it is F2. I'll put a dollar directly here. So it will be a dollar. Here also it will be a dollar. Here also it will be a dollar, and here also it will be a dollar. So I have freeze the cells, and it will be. So this is the deviation. So you can see the actual weightage. So this is the bigger sales, and the weightage to it is 99%, and this is having a weightage of 0.0009. So in this case, my weighted map will be the weightage multiplied by the map, and it will be the same here, and it will be, what you will do is actually you will sum this up, or let me just do it here. So the map was earlier, in this case the map was the mean of these, and the weighted map will be the sum. So in weighted map you need to sum these up. So it is saying the map is 11%. So this is more of so why do we need weighted map? So weighted map, actually you need to justify your models in front of client. Actually if you see this case, here the actual sales was 1, okay, predicted sales was 61. So only there was only like you mispredicted only the 60 products. So like think of a company like Coca-Cola. They are selling the product in lakhs, in like thousands and all. And it is a one store value, that is the sales was 1, but you predicted as 61. And in another place, the sales was 1000 and you predicted as 1060, that is 1060. Here, both of the case, the error was same. That is, you mispredicted 60 products. Okay. But if I see the actual case here, the MAP was 6000 because my base value, my actual value was very less. Okay. And company would not be impacted by these 60 products. So they will say, okay, no issue, you mispredicted. 60 is a affordable range for us. Okay. So they will say the MAP is 6000 here and here MAP is 60. So for the same product, for the same error, the MAP changes basis the actual values. So, and actually your MAP is highly impacted by the smaller values where the actual sales is very less. So if you see weight of actual sale, so what we will do is we will calculate weighted MAP. So this is from where the concept of weighted MAP comes in. That is in order to identify the weightage of the sales value. So you will do weightage of the actual sales. So you will identify that the sale which you are dealing with is what percent of the total sales. So it says your sale, that is 1, is only, so you will do 1 divided by the sum of these. So it is only, you can say 0.009%, and your 1000 is 99% of the total sales. So you will multiply your MAP. So you will multiply your MAP with the weightage of the actual sales. And similarly, you will do here. That is, you will multiply your MAP with the weightage of your sales, and here the MAP comes out to be 6% in both the cases. And in the weighted MAP, you will always sum it up. So the weighted MAP is 11%. Do anyone of you have any doubt in this? Any doubt? Harmeet, Raghu, Bhuvi? Bhuvi, is it clear?
Then why we need map, Gurdeep? Then so this is give the proper output, then result. Then where we will use map then?
So I would say weighted MAP is above MAP. Of course, you can give to the client weighted MAP every time. So you can show both MAP and weighted MAP to the client.
So anywhere map will be used then. So because it's giving wrong data, right? Then the result will be wrong, right? For this scenario. So then no
Correct.
need to
So
use
actually,
map, right?
yeah. So I would say your weighted MAP actually helps you in. So like for example, you will calculate MAP, and you will calculate a weighted MAP. So actually, by calculating both these values, you will also get an understanding that where my model is performing bad. Correct. So your model is performing bad where your sales value are very much low. Most of the time, see, most of the time, both of these value will be same. Most of the time, your MAP and weighted MAP will be same.
So can
but
we
in some
understand?
case,
So the data will have more variation by having these two results.
Data will have more variation.
For example, this actual sales and prediction sales. Okay,
Hmm.
so based on this two output, map and W map, if we have the more variance, then we can see the data have more variation. For example, the actual sales is 1, and another second line item will be 1000. But predicted sales is showing a 61, and another one 1060. So it's a lot of variation is there. So can we say if the value between this map and W map is more difference, then it does data have variations?
Correct, Raghu. So actually, yeah, you picked the point correctly. So actually, it shows that there is a huge variation in the data, and the model is not able. So if there is a huge difference, so it shows that your model is actually not able to identify, like, is not able to capture the variance. So what you can do is you can create a separate model for the smaller values. That is, if the sales is less than 100, you can create a separate model for it. Yeah, if the sales is less than 300, you can create a separate model. For if the sales are above 300, for all those data points, you can create a separate model. So correct, it shows that your model is not able to capture the variance in the actual sales value. Any more doubt anyone of you have? So, okay, from the business perspective, from this particular MAP and weighted MAP perspective, any question, please let me know. Is the things clear? If the things are clear, please write clear in the chat window so that I can get understanding. Okay, great. And yeah, uh, I think like okay. And Parul, one more thing. So one more time. Okay, like sorry if you feel offended by that. I didn't mean to that. I didn't mean to say that thing. But it was a simple request that okay. I that was a feel what I had, but not something negative or anything like that. Okay. So thank you all. So this is the end of our class. So thank you all. Take care. I'll share the.
Gurdeep, I have a
Yes.
question.
Yes.
In next station is also on Zoom platform.
Sorry, I don't have an answer for this question. This is the only question I don't have an answer. So I think like Swati, sorry, Damni and the other coordinators can help you out with this.
But can't you
Okay.
see from
I
your
have one
side,
more question.
Gurdeep, it's recorded or not the session?
It is recorded. That is what I got the confirmation. So Bangalore Online is recording the session. So it is being recorded from Bangalore. See.
Yeah, because here it is not showing. Usually, while you do it in Go meeting, it will show that recorded. It will show in a red color. Here,
Correct, correct.
so you are
Here,
not.
when you will see the
Yeah,
participant list, na,
it's
so
shown
you will get the
like
red color there.
right.
So
Yeah.
we have requested
Gurdeep,
people from Bangalore to, yeah, Rishabh.
I have one more question. Can you share the topics you discuss in the next session? Next session?
Topics to discuss means like the list.
Yeah.
Sure, I will just. So I think that is what you have as a syllabus content with you, or I will just, I will just forward it the mail to you, or I will just ask Damni to share the content with you, the topics which we'll be covering.
Yeah. So we will
So,
learn and we will uh, good for the topics.
sure, no issue. So thank you all. Take care. Have a
Thank you, guys.
happy week going forward. And if you feel any doubt, then please you can just mail me up, and I will be able to help you out. So thank you all. Have a happy week going forward. Take care. Bye.